Yeah, all right. So I just want to do a quick announcement. We are doing a hybrid setup for the workshop. So sometimes we'll have things that are specific in person. Sometimes we'll have things, as you saw the note earlier, for our live stream viewers. We can't provide support in the same way that we can provide for in person. But if you have questions, either in person or online, let us know. If you're online, leave comments in chat. And then once we get to a question portion, Alex will relay that to us so that we can have answers, or that we can answer your questions. If you have any questions or require any technical assistance in person, raise your hand and we'll come to you. And we'll also answer them as we go. Is there anything else? We'll have, because of the multiple sessions and breaks in between, we'll have a slide up on the screen that says like, hey, we're in a break. So if you don't see anyone in here, it's not canceled. We're just in between sessions. So I guess before we end up starting officially, I'll do the introductions. I'm Marcin Gallus, and I'm a software team manager, part of the Research Computing Center. This is Jo, and she'll be doing session 1. Alex is back there moderating, and he'll be doing session 2. Jose is back there moderating as well, and he'll be session 3. And I'll be session 4. And of course, we have our fearless leader, Paul, the back in the green shirt, and he'll also be able to help you. So definitely feel free to lock eyes with any of us to be like, wait, I need help. And Casey is the one that's been signing everyone in outside, and he's the one that also sent all of the login information via email. So you can blame him if there are any typos and thank him if everything worked. So without further ado, let's get started. Welcome to Python Bootcamp. I hope you enjoy.
Okay, welcome to Python Bootcamp. And my name is Julie, and I will guide you through the presentations and the hands-on sections from the very beginning of Python programming language. Okay, let's get started. Before we get into Python, I'd like to introduce a little bit about the Jupyter Notebook, which is the environment we're going to use today. So what is a notebook in computer science? Notebook is an interactive computing environment that integrates code and output, and also the documentation, such as text, visualizations, equations, medium, links. You can put whatever things in the in this notebook in a single document. If you see .ipynb file, this is a notebook file. I believe you have 4 in your workshop account now, right? And later after the workshop, we'll provide you 4 more with the solutions. And today we will work on this notebook. And now let's look at the interface of the notebook. And I'd like to show you how we can use it. When we talk about interface, there are 2 parts we should know something about. First, kernel. Kernel is the engine of the notebook. You can think of a brain of a human being. Kernel actually is the brain of the notebook, meaning it executes your code and provide you with the output. So this is what kernel does. You cannot see it, but it's backend process, and it's there all the time with you when you click and use the notebook. Make sense? Okay, and the next part is cells. Cells are the main working area we're going to use. And there are 2 types of cells. First, markdown cells. As I say that, markdown cells are the parts for the documentations, for the text, for all of the things you can put it in. And Markdown actually is the name of a formatting text language. If I double click here, as you can see that there are some syntax here, right? The syntax of Markdown we will not cover today in this workshop. You don't need to worry about it today. If we want you to insert a Markdown cell, you just insert one and then just do some texting here, just like you use Microsoft Word, for example. And for these formatting things, if you are interested, you can Google Markdown cheat sheet, or you can use some YouTube resources to learn about it. It is widely used not only in Jupyter Notebook. And how to insert a cell. Let's say, look at the blue bar here, right? If you want to insert a cell below this cell, what should I do? You can click plus here. Did you see insert a cell below? Yes, this is how you can insert a cell. But please note that when you insert a cell, by default, it is a code cell. So if you want to insert a markdown cell, you can make changes here and markdown. And now, this is a markdown cell. Make sense? And after you added the markdown cell, just click. Did you see here? There is something to run the cell, and this is here. So this is markdown cell. And another group of the cells is the code cell. This is the main part we're going to talk about today. Code cell is the part that you really write your code in, and then when you run it, you will get some result. And please take a look at this example. In this cell, and did you check here his code, right? So this means that it is a code cell. And if I click run, you can get some output here. Did you see the output? You can try, actually, you can follow me and try it, and raise your hand if you have any questions. And after you run this code cell, did you see the number next to the code cell? There's 1 here. This is keep tracking of how you run the different cells. So this is the first time you run the cell. And if I click again, I run it twice. So this is the tracking number. Make sense? Okay. Another thing I'd like to introduce you is that if you click view and there's a show line numbers here. Now we have another set of numbers. Did you see the 1, 1, 2 here? In gray, the numbers in gray. This is the line number of your code. These 2 numbers are very important for debugging. So you can keep these 2 numbers here. Whenever you have something wrong, it will show you that something wrong here. Make sense? Okay. Please note that if you insert a code cell and everything you type it here is the things the interpreter will read. Meaning, if you type anything wrong here, you'll get the error. See? So everything in the code cell must follow the syntax of the code. Make sense? But the things in markdown cell, you don't need to worry about it, and there's no error check about that. Make sense? Okay, good. Now, I believe you know how to insert a cell, how to run a cell, and there are some keystrokes and some easy ways to do that, and I can introduce those to you gradually in this presentation. And now, let's take a look of this session. What cell is it? Is it code cell or markdown cell? Code, good. But if I run it, nothing happens here. Why? The reason is that this is part in comments. Did you see the pound sign here? This is the comment. Comment is part of the code, but the interpreter will ignore it. Meaning, if you write something in the comment, it will not be interpreted and it will not provide you with the output. But comments are very important thing, and it is always a good practice to maintain a good comment. Why? code is always shareable, right? If you submit your code to your TA, your instructor, others need to know what's in that code. And comment is the things that you write down some descriptions about what is the code about, why I read this section of code. So always maintain a good record of the comments. And even for yourself, after 1 year, you will never remember what's in this section of code. So update your code along with the comments, and this is a good practice. Okay, and write meaningful things, just like what is the code about. If you write something like I'm so glad I finished this section of code, it's meaningless, right? And later on you will not know what happens in your code. So always maintain a meaningful comment in your code. Okay, this is the first things about it. Now, again, if I want to insert a cell, do you know how to do that? Click here. Another way is click, did you see the bars here? You can insert above, you can insert below, or you can delete it. Any questions about Jupyter Notebook? If you don't have any questions, just do the first exercise, which is to insert a markdown cell and write down one thing you hope to get out of Python Bootcamp. I will give you 1 minute to do that, and then I will do it together with you. Raise your hand if you have any questions, okay? So just remember how to insert it. Use the plus here. And then remember to make the changes from code cell to markdown cell, right? And then you can write something here. I hope. And then click run, save it. And that's it. Any questions so far? Good. Now, let's talk about Python. Python is one of the most popular programming language today in the world, right? But what makes Python so popular? In other words, why do you choose to learn Python today? Any thoughts about that? Why do you want to learn Python? Yes, please. AI. Okay, yes, right. So it is widely used in AI, machine learning, data science, automation, web development, almost everywhere, right? And Python has many good features as well. For example, readability. When we see readability of code, the meaning is that the syntax of Python is close to our human language, and the other side is machine language. Make sense? And second, Python has extensive libraries for different domains, right? And third, Python is an interpreted language, meaning the interpreter will execute your code line by line. This is compared to the compiling language, which is C++, Java, Fortran. For the compiling language, you must finish all of your source code and then compile it and then run it, right? Python, you don't need to do that. You can run it line by line, as we show here, cell by cell, so such that you don't need to finish all of the source code. You can get partial result of it. And another good point of it is that it's easy to debug, since you can locate it back to that exact line that has narrow arrows, right? Make sense? Good. So this is Python, and it's very good for beginners. So today we're going to cover two main topics in this section. We'll talk about variables. what is a variable, how we can use the variable. And since variable can store only one value, if I have more than one value, what should I do? And so that is the next topic about list. Okay, let's get started. Oh, before we get to Python was developed by Van Rossum in 1980s, and he is a Dutch programmer. Okay, let's get started about variables. Variables is the first very important concept in coding. Let's take a look at the example. In Python, we can write the expressions like this. And then if I run it, you can get the result, right? But it is always a good practice to maintain these expressions or values into a variable. Why? You can think of that if you later on you want to reuse this line. If you do not have the variables, you need to copy and paste everywhere, right? But if you want to make changes to this line, you need to make changes to all of the places you reuse, right? But if you maintain a variable here, if I make changes, I only need to make changes to this line. Make sense? Yes, variable is very important to manage, to store, to manipulate data in coding. And what is a variable? It is a storage place with a name. And then you can assign a value to this storage place using the assignment operator. So this is as simple as what you did in math class, but actually the meaning is different. In math, if we use equal sign, which means that the two things on the two sides is equal, you can swap it, right? But here you cannot. Why? If the computer read this line of code, what it does is that it will first create a space. You can think of a box, a container, and this space is called, this is the name associated with the box. This is the variable name. And then I put the value 25 into this box. So on the left side of your equation, it is the name of the variable.
Oh, no.
And the right side is the value. Now let's look at some examples. This is how I define the variable, and then I just print it out and you'll get the result here, right? Now, the how I do the assign, I use the operator equal, but make sure that the equal sign is different with what you did in your math class. If you want to compare two values that equal in computer science, we use a double equal sign here. I will talk about it later, okay? And let's look at the rules of variables. First, before you using a variable, make sure to define it. Let's run the first cell and see what happens. Arrow, why? It says that odd is not defined, right? I use the variable, but I do not define it. So how to fix it? I can define it here by assign a value to it. And then I rerun, there's no arrow, right? So this is the first rule, define and then use it. Okay, let's look at the second one. This is another rule. Why? Because on the left side of the equation, it should be the name of the variable. And right side is the value, right? So how to fix it? Wait equals 60. And comment out here. And now it is correct, right? But the thing is that, does it mean variable cannot on the right side of the equation? Let's look at this line. I use weight2 equals weight. Is it correct or not? Yes, it is. There's no arrows, right? But why is correct? Because in this line, what I did is that I use the value of weight and then assign it to another new variable with 2. So this is something about the different meanings of variables and value. If I write weight 1 equals to weight, if the computer read this line, what does the computer do? It will create it. So first, you already have a weight with 60, right? And this is weight equals to 60. And then you have weight 1 equals to weight. What does the computer do? Created another box. And then for the value of this new box called weight 1, it will extract the value here and then copy the value. So this is the meaning of copy.
Question,
Yes, please.
if you have them flipped, would the same happen, like if you had, let's say, weight equals weight 1, would it be the same?
I can't hear clearly.
So the question is if weight 1,
Uh-huh.
if it's reversed, so weight equals weight 1, what would happen?
Oh, you mean that for here, weight equals weight 1? So pattern here. Did you define weight 1 here? If you defined, this is correct. But the meaning is that you will subtract this number to weight 1. So always remember that on the left side is the variable with the name, and right side is only for the value. If you use this line here, if you define it like this is correct. If you don't define it, this line will show you an error. Make sense? Yes. Yes, please.
When I run the line, maybe about 11, it won't give me the result. Yeah.
Oh,
no.
yes, that is another thing. We run the code, but it only do the calculations here. If you want a result, you need to print it out.
Okay.
If you print even, it will get the result. Make sense? Yes. I'll talk about the function later. Okay, let's look at let's run the cell and we get weight 1 equals to weight. And now, since the name is variable, can we update the variable? Yes, we can make changes of that, right? So if I use weight equals to 75 and then 68, when I print here, what is the result? What is the output?
60.
Yes, very good. But what does the computer do here? We have, let's reuse this box, and we have 60 here. When I see equals to 75, the computer will erase this number, but still reuse this box, and then change it to 75, right? And to the next line, it's 68, and then wipe it out and 68. So this is the meaning of this simple line. Make sense? But if I run the code until 68, and you are correct, the printout result is 68, how about the previous values? It's overwritten. So this is the things, the tricky part, because if you want to use a 70, for example, for calculation, you need to run that code. If the code gets to this line, 75 will not be there, and 60 will not be there as well. Make sense? Okay, cool. Let's print the result. Yes, 68. Now, like password, variable names have some rules. You must use letters, digits, and underscores. These are the only 3 types in a variable name, and it cannot start with a digit, and they are case sensitive. Another thing is that you cannot use Python keywords. These are the reserved words in Python language. It has different reserved words in different programming language. And this is how you can get this list. And let's look at the examples. Here are the examples of good variable names. And as we can see that, we only use letters, underscores, and underscores letters, right? And let's look at this one. Why? Why we have the arrow? Remember the second rule? Digits cannot at the beginning. Cool. And how about this one? Weight equals 128 and weight equals to 0. Are these same variables or different ones? Yes, because the uppercase and lowercase, they are different things, okay? And let's look at the last one. What happens here? Return is the reserved word here. So you cannot use it as a variable name. So you can change it to return value, something like that. And it will fix the error. Make sense? Yes, good. Let's do exercise 2. Yes, please.
Can you explain the keyword, keyword list? The like
Oh, you want to know what does they have?
the format, the print keyword KW list.
Oh, this is how you can use the important library. I don't want to explain too much here. You will learn that in the afternoon. Is that okay? Okay, here I just want to show you what are the keywords, and you cannot use keywords for variable names. Is that okay? Let's look at exercise 2. So let's do this exercise together. Now, for first question, are these variable names valid or not? So the first one, age equals 25, is it valid or not? Yes, good. Next one, the second one, is it valid or not? No, why? Because of the number, right? Okay, next one, is that valid or not? Yes, please.
How can I edit, like want to put under the comment valid, invalid? I tried to edit something.
Just double click the cell. Does it work? Okay, next one, total amount, is it valid or not? Yes, good. Next one, is that valid? Good. User height, is it valid or not? Why? Cool, you guys are great. So next one, is that valid or not? I hear no. So some yes, and I hear yes. So let's check it later. So for the last one, is it valid or not? No. Good. Okay, let's this one I just commented out because all the above are correct. Let's check this one. No, this one is invalid, right? User. Okay, let's check. The arrow is coming from class, which is invalid. You are correct. And this line is correct. Why? Because you can use underscore at the beginning. Only digits cannot start at the beginning. Okay? Yes. And the 3 I commented out invalid ones, and all others are valid. Okay. Let's take a look at the second question. Let's do it together. It's not that hard. Height equals to 3.6, and then height equals to 5. If I print it here, what happens? So what is the number? What is the output? Cool. Okay, any questions so far? Yes, please.
So underscore user is valid.
Yes. You can check it, and after the workshop, you can check it one by one, and if there's no error message, it means it's valid, okay? Next, Python is dynamically typed. What does it mean? It said you do not need to declare the type of the variable. In C++, you need to declare the type first. So you can just use directly, but how does the computer know that what type is it? You must assign a value to it. From the value, the computer know that, oh, this is the type of that variable. Make sense? Okay, these are the data types we're going to use in this workshop. And the first one is integer. This is the whole number, right? And the second one is the float number, float variable. The third one is a string. And a student, this is called Boolean variable. You may not that familiar with this one. For Boolean variable, it only has 2 values, true or false. Okay, we'll use it a lot in computer science. And let's print it out and see. Yes. And how do you know that it's a float number, integer? the, yes, the floating point here. If you check the type, it's floating. If I delete the point, it is the integer. Make sense? Yes. This is something about how you can use string in Python. You can use either single or double quotations to let the computer know that it is a string, and there's no difference of the first two. And for triple quote, for multiple line strings, just use the triple quote. Okay. And this is the example about double and single quotation. No difference of it. And let's see what happens here. The mismatch of the quotations, right? And you must use either double or single. And this is some rules of the strings. If you have double quotations inside your code, so use single outside, and vice versa, right? And this is multi-line strings. And that's printed out. Yes, Python. And string can be a number, but how do you know it's a string? Quotation mark. Yes, you're right. And how about here? Is it a string? No, it's an integer. Cool. And string can be a phrase, and string can be a mix of numbers, letters, and symbols. Okay, good. Let's do exercise 3. Would you please create a variable to store your name and another variable to store your date of birth and print them out? Second, create 2 variables to store 2 different numbers. Make changes to the second one and then calculate the sum and print it out. I will give you 2 minutes to do that, and raise a hand if you have some questions. Okay. For the first one, yes, I'm sorry.
Is it possible?
Yes.
It's too.
Yes.
So, for the data type, there are date type. So date is a string or date. There is a type for date.
If there is a symbols within the string, that is a string.
Okay, but there's no date and time as a separate type, right? So date belongs to string.
If you use any of the symbols on your keyboard, that is a string.
Okay,
Make sense?
yeah.
If you use numbers only, that is an
Yeah.
integer. Okay, sounds good.
I don't understand.
What's the shortcut to replace the run?
Oh, that is Control Enter. You can try it. That's easy to use. Control Enter.
Okay. Yeah, it works.
Oh, works, right? Cool. Okay, you can do, and I will show the result here. So for name, you need to write a string, right? And this is date of birth. And the question is very good. How do I know that it is an integer or it is a string for date? Because I provide you with the format here. Since there are some symbols there, it is a string.
Yeah.
If you do not use quotation mark, you'll get errors. Make sense? Yes, please.
Why double quotation marks and not single quotation marks?
Either one works.
Okay,
For a single quotation and double quotation, it's interchangeable, okay? And if you run it, it will work, and then print it out. You need to print out, use print, and then name, date of birth.
And some programs.
Okay, for the next one, I'd like to show the result here.
Yeah.
but it sounds like I'm giving her off if I do double. Yeah.
So typically, do you think this section of code is a good answer to the second question? Yes, it is correct, right? But actually, it is not a good one. Why? Because the variable name I use XYZ, it is not good to use it as the variable name unless it is within a very small scope. Otherwise, you need to use some meaningful things for the name of the variables for the readability of code. Make sense? So this is correct. But if you can make the names to something meaningful, just number 1, number 2, that should be much better. Okay? Now, let's talk something about how to use it. When we say how to use variables, we need to manipulate with the operators and to get a new one, or we need to compare the two values of it. So this is the things about operators. Operators is another important part at the first beginning of the coding. So we have already introduced the assignment operator, right? And now there are two more types I'd like to introduce. First is the arithmetic operator. This is the exactly same thing as what you did in math class. And only two of them I want to mention. One is floor division, the other is modulus. And these two are widely used when you learn loops, and you will learn loops soon in the next session. Why? I'll give you an example. Now we have some students here. If I want to divide you into 3 groups in coding, how could I do that? I can run a loop and put the remainder 0 students into one group, and remainder 1 into another group, and remainder 2 into another group. So this is how we use modulus. We keep the remainder only. And the floor division is to keep the quotient only. For quotient, the example is that if I want to know how many students in each group, I will use the floor division. So these two are widely used in the algorithms. So relational operators is another type. Equal to, this is the mathematical equal. And not equal, greater, less, greater or equal, less or equal. So these are the things you are going to use. But different from mathematical class, but if we do check the value, the return value is true or false. Make sense? Okay, let's look at the notes. This is the examples about use expressions. And if I have number 1 equals to 13, number 2 equals 5, I can do these calculations here and print the result. And this is how to use the mathematical operators. And plus operator can have more meaning than addition. You can use it as concatenation, meaning that you can put 2 strings together, use plus. This is how you can do it. And 1 string, another string, and I put it together using plus. Make sense? Yes, please.
I don't understand what a screen is.
What string, right?
String.
Oh, this is, I just print out the type. I just want to let you know that if you want to add concatenate 2 strings, the type must be the same. So this is just print out the type.
Thank you.
Okay, and this is how you can concatenate strings. This is the one way, and put it in another variable, and this is just use print function. Okay, and they did the same thing. Now, relational operator. Relational operator will return true or false. And it is very important to for future coding, when you make decisions, you need to check the conditions. And if it's true, go to one way, and false, go to the other way. So the code will have more than one path. Make sense? Okay, let's look at the example. If I have two numbers, I have result 1 equals to num1 is larger than num2. So how to do the computer do this line? Check this first. It is greater, it is true, right? And the result true will be printed out. Next one. These two numbers, we'll check this part first. Is it true? No, so the result 2 is false. Make sense? Now, yes, please.
Confused. So basically, the question is that which one you evaluate?
Yes, that is the things I'm going to cover now. So which part of the will be evaluated first, right? So let's see. In this statement, I evaluate this part first, but why? This is the problem about operator precedence. So if you want to know that, let's say this is the list of the precedence operators. Meaning, when you have more than one operators in one sentence, the order is like this, from highest to lowest. And if in one line there are several operators in one line, you need to evaluate from left to right, just like what you did in math class. Make sense? Yes, cool. And let's look at the examples now. Oh, I'd like to mention two things. First, parenthesis has the highest priority. Means that whenever you use parenthesis, it will override the default precedence. And assignment operator has the last priority, meaning that you need to get all the results first and then put the value in assigned to a variable. Make sense? Yes. And these are the mathematical ones, and it's exactly the same as what we did in math class. And these are the compare operators. And let's look at the examples. My calculator equals 2 minus -1. So how to evaluate? This is first, and then 2 times -1 is -2, right? So the result is -2. Next one, 2 plus 2 times 2 minus 2. Which one to evaluate first? First, 0, and then second, another 0, and then third. I should have 2 here, right? Let's print out to see the result. Yes. Now, let's use some exercise to understand the operator precedence, okay? Let's do it together. First, if my calculator have this expression, for the first one, which one we should evaluate first? This part, right? 2, and then times 2 equals 4, and then 6, and then I will do 6 minus 4 and plus 6, right? So what is the answer should be?
I did go into that because I started evaluating it.
And let's check the answer later, okay? Now, next one, which one to evaluate first? Parenthesis, good. So we'll do 5. And next one is 10, right? And then do the division, 2, and then do the plus and minus. So the answer is 5. Next one. Which one to evaluate first? Parenthesis, 2. And then I will do 2 times 2, 4, and 8. And then last, do the plus. So the answer is 10, right? Cool, let's print out the result to see. Now let's do the second question.
How do I print partial code?
How do you mean partial?
Like the first line and second line, if I highlight that and hit run,
For example, you want to print the,
only that, yeah. Only that.
it's actually comment out the,
Okay, you can now just highlight the one that's.
anything you don't want to print it out, just comment out or delete that line. Yes. And the second question is almost the same as the first one. So I will leave it for your after workshop and I will continue with the content. Is that okay? Now, let's look at the built-in function. So this is a section, we have already covered a lot. I want to let you know that function, especially some built-in functions that we can use directly. When we talk about functions, it is the block of code that later on you can reuse it. And that code is for a specific thing, for example, print. And I will show you, this is how you can print one thing. And this is you can print out multiple things using the comma sign, right? And you can also use functions with some other functions, like what I did here. I want to print the type of the variable. And this is one function I use, and then I use another function to print it out. And the help function is help you learn this language, Python language. For anything you are not familiar with and you want to learn in your coding, use help. And it will tell you the syntax here. Make sense? Okay, so this is something for a break, and then we'll talk something new here. We have already talked about variables. As I said in the beginning that variable can hold only one value. But if we have more than one value to store in somewhere, what should I do? In Python, we can use list. So let's think about the example here. Imagine there's a temperature sensor that taking hourly readings outside your office. And I want to have 5 of them recorded. So what should I do if I want to store these 2 sets of data? If you use variables, you will have 10 variables to hold 10 different values, right? But what if I want to put it in one thing? This is what we call list. List in Python this is the first data structure we're going to introduce today. And list is an ordered and mutable collection of items. What does it mean? Meaning that the things in the list is numbered. It has exact position, and you can use that index number to locate that item. Mutable means that you can change the value after you create the list. Let's look at the examples. The basic syntax of creating a list is that you can use the list name and then the element 1, 2, 3 separated by comma. And let's see. The examples, think about the example above. I have 2 sets of data, temperature readings, 5 of them, and time, 5 of them. So if you want to print out this list, what should I do? I can print out the name, put it here, and I just simply print it out, and you can have the whole data of it. So just like what you use about the variables, but it can hold more than one piece of data. Make sense? Okay, next one. This is how I can print it out. Much more fancy, actually. I'm using the for loop here. So for the meaning of here, Alex will talk about it shortly. So I don't want to go too much about the syntax here. So just remember that I can use a for loop to print out the information. But I have 2 questions about it. First, how many times I print it out, run this line of code? 1, 2, 3, 4, 5, right? And another question, what is the number of index? Do you know that? Let's check it. If I want to print the index number, is it 1, 2, 3, 4, 5? No, it's from 0 to 4. So this is the next thing we're going to talk about, indexing, how to number the list. As I said that list is a numbered data structure, means that every element in that list have its specific position. And you can always use the index number to locate that. But please know that the index encoding language, not only in Python, it's getting started from 0 to n-1. It's not from 1 to n. So this is the things you need to remember. So if I want to print the third item in the list, how could I locate it? I should use index number 2. Always remember n-1. Okay, let's see. Is that the third one? 1, 2, 3. Correct, right? And if I want to print out the first and last item in that list, we have 5 of them. So the first one is index number is 0. And the last one is 5 minus 1, 4. Let's say, yes. So this is the things about indexing. And another thing is that if you know that element and you want to get the index number, you can always use a method to check it. And index is the method you can use in the list to get that number. Let's see. So here, I know that there is an element 22.1. 22.1, and I want to get the index number of that. The index is 3. Let's check whether it's 3 or not. 0, 1, 2, 3. Make sense? So this is how you can get the index number. Now, let's do some exercise on list. Yes, please.
I'm just trying to figure out why would I want these index numbers?
You need to locate it. For example, you have a very large database data, and I want to search from somewhere. The computer needs to know how to search it, right?
Or if you have 2 arrays, like the humidity and time, you want to have the fixed time and the fixed humidity. You need to have the index. If you want to address individual elements.
Okay.
So it's individual for the data?
Yes.
Yes.
Okay.
Is there another question?
Okay. If
So-
you do not,
So the index is only counting the number in the list.
yes,
Okay.
that is to tracking the element in that list. Make sense? Yes. If you do not have questions, you can get started with the exercise, and we will here to help you. So the first one is exactly the same as what we provide in the example. It is a sensor to record 2 things. One is time, the other is humidity. And you need to create 2 lists to maintain it, right? How to do that? And then you need to print out the information. And please note that the most important syntax is to use the bracket here to let the computer know that it is a list. It is not a variable, okay?
Yes. Yes. Onion.
Okay, I'm going to go slowly with the result, and for those who have already finished, let's check it, okay? And this is the to list I'm going to create, exactly the same thing as what we did. Make sure to run this cell, otherwise you will get some errors because you do not define it. Actually, you define, but if you don't run it, the computer will not know that you define it, right? And this is how you can print it out. And if I want to print out the fourth item, I need to print out index 3.1, right? Make sense? Yes, good. And if I want to find the index of the specific item, I need to use index. And then you can find that the position is 2. This is the index number, which means that it's the third position, right? And let's see what happens to this one. Arrow, why? Because this item is not in the list. Make sense? So if you want to search something and it doesn't contain that element, you will get error in it. Okay? So list can contain any of the data types. So I've already talked about integers, and this is characters, and this is the list of strings. And it can also use mixed data type to hold the list. And this is the example of integer and float number and Boolean value and string and character. And this is the nested list. And you can also create an empty list. Okay? So mutability is another feature of a list. It means that we can make changes to a specific item. For example, this is the language example. And if I want to make changes to the first item, how could I do that? I can use language and then use the index number to locate this one and then make changes. This is just like what you use for your variables. And if I make changes for the first item from C# to C++, and you are done with it. Now, the list is C#, right? So this is, I can answer the question of, she just asked why we need the index. This is why. Because if you can locate to each of the items, I can do a lot of operations here. Make sense? Okay, I think time is about, we have some time. For those you have already done, you can get started with the exercise. For the rest of the content, if you are interested, we will provide solutions for that and give us some feedback. If you are interested in, we can include the following content in the intermediate Python later, maybe. So this is exercise 6, and let's do it together. And we are done with this section, okay? So in this exercise, would you please create a list containing your name, student ID, your or FSU ID, score, GPA, and for the Python class. So this is the mixed data type of a list, right?
That's the one she did.
Okay, I will go with the solution for this exercise. And I want to maintain a list to store all of the information. For example, name, you need to maintain it as a string. And then FSO ID has some characters and numbers, so we need to maintain it as a string as well, right? And then this is the number you can use directly, that is a score. And for GPA, it is float number you can use directly. And the Python course is the name, so you need to maintain it as a string. And put all these things with the bracket and name the bracket as my course. And then you can print it out. Okay, this is the first question. Second one. I want to maintain a list, have these languages here, right? And maintain it as strings. And how to make changes to the third one? Use the index F language. So the third item, the index is 2, right? And then I make changes to that one and then print it out. We have make changes from German to Spanish. Make sense? Okay. Yes, please.
Is it possible instead of putting the index number, just put just German and then change it to Spanish, like with the word
I
German?
don't think so. That is the syntax of the language. So that is a very good question. So I still feel that you feel confused about the index number, right? So this is the last thing I'm going to present today. And I will show you why. So this is the variable. When you talk about the variable, it is the single box. You can think about this, right? For list, actually, the data structure is like this. It is a consecutive box
Yes.
to hold the data. So why is consecutive? You can need to make changes to them, and you can add something to them and delete something to them. Since it is a consecutive location to store multiple values. If you want to locate back to some values, how could we do that? Index. So in that memory location, actually we have 0, 1, 2, 3, 4, 5, and for each box, you can store one value. This is the background meaning in memory about the list.
Okay, well, we're a little over time for our break. So just to keep with the schedule that we have, if you have any questions, just let us know during the break. But we're gonna start our 10-minute break and we'll be back at 10:45. So see you guys in 10 minutes. Yeah, that's fine. Yeah. Okay, so it's 10:45, almost, yeah, that's 10:45. We'll get started on session 2. I will say, I know that like the Python Bootcamp is pretty quick. In terms of like, we're trying to squeeze a lot of Python in 4 hours of the day. So we, along with I mean, you've heard the audio, so the recordings, we have the recordings of the presentation, so you'll be able to follow those along at home. We'll send those with you, along with the solutions afterwards. So if you get lost, again, like raise your hand and we can talk you through it here. But also if you want a little bit more time with it, we'll have the video recordings to send as well. So without further ado, we'll start session 2 with Alex.
All right, thank you. So as Marcelina said, my name is Alex, and I'll be presenting the second part of this bootcamp. So as always, if you have any questions, raise your hand, and I'll periodically stop. I'll stop periodically for questions as well. So to get started, let's review a little bit about lists. So we just finished learning about lists in session 1. So remember that a list is just a set of values that you store between brackets, and within those brackets you can put numbers, you can put strings, you can put characters, you can put variables. But it's essentially a list of items that you store. If you I'm probably gonna sound old by saying this, but if you ever like make grocery lists on a pad of paper, you can kind of think of like writing 1. You know, you write 1, and then you write eggs, you write 2, you write bread, you write 3, you write fruit, and then the index is the number of the item in that list. So for example, if you have a list in Python that has eggs, fruit, and bread, then the first item will be eggs, the second item will be fruit, the third item will be bread. Now, one thing to keep in mind is that Python starts counting the number of items from 0 instead of from 1. So whereas in a regular grocery list you might write on paper, you would write item 1 bread, or eggs, item 2 fruit, item 3 eggs. In Python, you would actually go back 1. So item 0 would be eggs, item 1 would be fruit, item 2 would be egg, item 2 would be bread. So that's one thing to keep. There are vast historical reasons for that, which we won't get into here today. But just remember that item 1 is actually item 0 in Python lists. So lists can contain any Python object, including other lists. We won't go into that, but you can have multi-dimensional lists too. You can have lists of lists. So that's one way of storing matrices if you have big data tables, if you have big tables of data. Lists, like I said, lists are indexed with square brackets. So for example, list 0 will print out the first item of your list, and list 2:9 will print out the second through the 9th items of your list. And it's kind of this indexing also works for strings, which we'll see a little bit later. And the other thing to remember about lists is that lists are mutable, meaning that you can change their values in place. So if you want to reassign a value within a list, you can do that. And that's the basics of lists. Do we have any questions about lists before we go on with session 2? Any online? No. All right. So the first new item in session 2 that we're going to cover is how to repeat actions with loops. We saw a little bit about this in session 1 at the very end, where we introduced for loops. So loops essentially answer the question, how do I do the same operation on many different values? So in code, you're often going to want to repeat the same action multiple times in a row. So for example, you might want to repeatedly add a certain value to a bunch of items in a list. Take this example list, for example. If we have a list of odds, which is odd numbers in this case, I can create that list by putting the numbers 1, 3, 5, and 7 in brackets. Now, let's say I want to print out all the items in that list. So if I don't know about loops, the first thing I might think to do is print out odds 0, print out odds 1, print out odds 2, print out odds 3. Print out each one, and print out each item and each item one at a time. Now, why might this be a problem? Any ideas? Very much so. Very much too tedious. I don't want to type all that. Any other thoughts?
You have a longer array than 1, 3, 5, and 7. You could be there for days.
Exactly. The other, there's one other issue. Anybody notice it? Huh? Resource? I'm sorry?
The same resource, like or something like that.
Not entirely, but if you get too big of a list, this is your code's going to get huge, and then yeah, you can end up with resource problems. The other issue I'm looking for is that if you were to change the items in this list, all of a sudden one of these would break. Let's see an example of that. Let's see what happens if I change the item. Huh? If I change the list of items from 1, 3, 5, 7 to 1, 3, 5, but then I forget to delete the last print statement here, watch what's going to happen. I'm going to get an error. It'll print out the first 3, but then that last one is going to say list index out of range. And that error means, hey, wait a minute, you asked me to print out the 4th item in the list, but my list only has 3 items. I can't do that. So this is another thing. If you end up changing the size of your list later on in your code, but you still do these multiple print statements, you end up having to change your code in multiple places at once. And that, going back to the tedious point, that becomes very tedious. If you have a very long code, you may be changing your code in 5 or 6 different places. And I don't know about you, but whenever I've had to do that, I always end up with errors. And I always have to fix I always have to run my code, realize, oh crap, there's another error. So fix, run, error, okay, fix, finally. So we want a better way to do this. We want a better way to iterate through lists and iterate and repeat the same action multiple times in a row. A better way to do this is something called a for loop. And the general structure of for loop is simply a way of saying, I want to do something over and over and over again for a certain set of items or up until a certain point. So in general, it looks kind of like this. You would say for variable in collection, and that variable is something called an iterator. This variable will change value every time you go through the loop, and we'll see this later on as we go through examples. So let's look at an example here. Remember that odds list I had before? Odds 1, 3, 5. What if I printed for odd in odds? What if I did this for odd and odds, print odds, or print odd? What this will do is I will be defining a variable called odd, which at first takes on the value of the first item in the odds list. And then I will go into the loop and print that value. But then it'll say, oh wait, there's more items in this odds list. So it will go back into the for loop, and odd will become the second item. And then it'll print that, and it'll print that value. Then it'll go back and print the third item. And it'll keep doing that until it runs out of items in the list. So let's see how this looks. So if I run this loop, I will get 1, 3, 5. Now notice what happens if I change the list from 1, 3, 5 to 1, 3, 5, 7. Now there's 4 items in the loop. And at this point, because this line of code tells Python, make sure that you keep printing odd until you run out of items in the list. Now I can rerun this code and it'll print 1357. And I can do that, and I can do this over and over again to change how many items I want in the list. So yes, question?
What's the advantage of using a for loop as opposed to just saying print odds?
So in this case, in this particular case, there's not much of a difference. You can't, what the user back there, or what the student back there mentioned is a very good point. One thing Python will let you do is you can actually print out an entire list. So I could do print odds, and that'll print out the entire list as well. In this case, there's not really much of a difference. But let's say, for example, I wanted to change the value. I wanted to add a certain value to odd every single time. Like I wanted to do print odd plus 3. Now all of a sudden, you kind of want a for loop in order to do that. So the advantage of for loops really is doing the same thing to each individual item of a list over and over and over again. Yeah.
I'll add to that, like, it's, we're using print statement here to kind of show what's happening, but any calculation that you only want to interact with one of the values in the list, is why you would use for loops over trying to like add them all individually. So yeah, so if you know something's gonna impact the entire list, that's why you would use a for loop. And then,
Question from online, was odd, not odds, odd declared somewhere else before?
No. So that's a very good point. If you want to make sure that the variable you use as the iterator in your for loop is not defined anywhere else. If you define this somewhere else, all of a sudden your for loop might get confused. So you want to make sure that this value has its own name. Now, yes, technically it might get redefined, but I wouldn't risk that. Yes?
So I just did it where I had 4 odd and odds print odd, and then 4 odd and odds print odd plus 3.
Mhm.
And I thought that my second odd was going to replace the first, but that's not what happened. It actually printed all of the numbers, the odd numbers. It printed both 1, 3, 5, 7, and it printed 4, 6, 8, 10, which is odd and odd plus 3. And I'm a little bit confused because earlier we were talking about how if you redefine a variable, it replaces it.
So if I'm understanding you correctly, you wrote 4 odd and odds, print odd, and that printed out 1, 3, 5, 7. And then you wrote another for loop that says 4 odd and odds, print odds plus 3.
Right.
So that's because what happened there is that when you wrote the first for loop, odd got defined for that for loop only.
Just that for loop.
Just that for loop. And then when you went to the second for loop, it got redefined as a new variable. So this is kind of why you don't want to put that, you don't want to define those outside of your loops because then it might get a little bit confused.
Yeah.
But within those loops, that's something called variable scoping. And in that case, it's a local variable. So the for loop alone is the only thing that can see that odd variable.
Okay.
And then when you go to another for loop, you'll be able to see that, then it will redefine itself.
It'll redefine it again.
Yeah.
Okay.
So, any other questions? Cool. So let's look at another example. So let's say that I want to find out how, let's say that this is another relatively trivial example, but let's say I have I want to count the number of items in my list, but I want to do it in a for loop so that I can change the size of the list however I want. So let's say I have a list of scientist names, and those are Curie, Darwin, and Turing, because those are the first 3 I could think of when I wrote the example. And now I want to go through a for loop and say 4 scientists and scientist names, and then I want to count up the scientists. So in order to do that, I need to start with a variable outside of the loop called number of scientists, and that has to be equal to 0. And then when you do this is not being referenced in the for loop itself. It's being referenced this is not being so this number of scientists here doesn't show up as either the iterator or the collector or the collection within the for loop itself. This allows you to define something called a global variable within the code so that you can change that value within a for loop and then keep it outside the for loop. So number of scientists equals 0, and then for scientists in scientist names, number of scientists equals number of scientists plus 1. And then at the end, I can print out there are a certain number of scientists in the list. So here I can print out there are three names in the list. So if I had not had that number of scientists outside the for loop, I wouldn't be able to reference that name. Because that's creating a variable outside the loop that you can then update. So this is useful because one thing you can do here, because when you do this, you can either count up items in the list, you can do calculations over a whole set of lists. You can define a variable outside of your for loop and then use that within your for loop. And that can be helpful for calculations. Are there any questions on this? All right. So just a note, be careful with variable names though. If you use a variable name in a loop that you assigned, I already said that, if you assigned elsewhere, the variable of that value will change and the loop progresses. So yeah, this is an example of what we were talking about before. If I define the name scientist outside of the for loop, it will start, and then I try to use the variable scientist as the iterator in the for loop, then this value will get overwritten by whatever is in the for loop. So scientist may be equal to Rosalind now, but at the end of this for loop, but when I go into the for loop, it's first going to get changed to Curie, then to Darwin, then to Turing, and at the end we'll see that after the loop, the scientist's name is Turing. So this is an example of be very careful about defining global variables like that. If you define a variable outside a loop and then try to use that variable as the iterator in the loop, you can run into problems of, well, wait a minute, this got redefined. What do I do now? So just be careful with names like that. Are there any questions on that? Yeah.
Sorry, can you go over that again?
Oh, certainly. So let's say that I start out in my code by defining a variable with the string Rosalind in it. Now, I want to use this now, and later on in my code, I write a for loop that iterates through a list of different names. Now I want to use the variable scientist as the iterator variable to go through that list. So now there's a bit of an issue here because I defined scientist up here as Rosalind, but now I'm using that same name to go through that list. So what this is going to do is overwrite this variable with the values that happen to be in the list. And at the end of this list, and every time it goes through this list, it's going to print out whatever the current value happens to be. So it'll start out by overwriting Rosalind and putting the name Curie in scientist. And it'll print that out. Then it'll go back through the loop and overwrite scientist again, but this time with the name Darwin. And then it'll print that out. And then it'll do that again, but this time change the name to Turing. Now, after the loop is done, this Rosalind is gone. And now it's just Turing. So the example here is really just to say, be very careful with how you name the variable that you use in a for loop, because it'll overwrite values. Does that kind of explain it? Cool. Yeah.
Yeah, so after the loop, you see the name is going to point to the last. Although if it's for numbers, then it's going to point to the last number.
Yes, correct. It will point to, so whatever, at the end of the loop, scientist will be whatever is the last item in the list that you're iterating through.
The iterator should it not be an integer always?
I'm sorry?
I'm saying that the iterator should it not be an integer always? The Rosalind, for example, should it be like a number?
Should this be a number?
Yes.
Oh,
Voice it.
So no, not necessarily, because scientists can't, so you can iterate through anything. A for loop doesn't necessarily have to reference indexes in a list, it can reference directly to items in the list. So scientists here, I start out with Rosalind, just assigning a variable to a string, and that's outside the loop. But then I use scientists to go through each item in the list. So each item in the list, so then scientists, as I go through the loop, it will directly reference a name of the list over and over. Yeah,
Question online, not the whole list at the end of the loop, just.
just the very last value in that list. Any other questions? All right. In that case, we're going to go on to something that we're going to go on to how to iterate using indexes. So going back to your point a little bit earlier, shouldn't for loops be numbers? In most cases, in many cases, yes, you'll be using numbers to index list items. And in this we're going to show that. So Python has a built-in function called range, and that range function generates a sequence of numbers between the two limits, between either the high limit that you give or two limits that you give. So for example, if I put range 3 here, what that will do is give me it will give me a sequence of numbers 0, 1, 2. So the first three integer numbers. If I ask for range 2, 5, what that will do is give me a list of numbers starting at 2 and ending at 1 before 5. So 2, 3, 4. And this is the reason why it doesn't stop at 5, it stops at 4 is due to Python's indexing. You should always think of the top number there, 5 or 3, as being one more than the highest number you want. It's just a feature of Python. And there are long historical reasons for why indexing is done that way. But this is just one of those slightly confusing things. You can even ask for a range of numbers that skip numbers. So for example, if I do range 3, 10, 2, I'll get every second number between 3 and 10. So 3, 5, 7, 9. And what that is saying, when you say range 3, 10, 2, you say, hey Python, I want a sequence of numbers starting at 3 and ending at 1 below 10, and I want every item of that sequence to skip 1. So, for example, if I do print list range 3, now the reason why we put list as a function here in front of range 3 here is because of the kind of data type that range is. Range is a type of data that is a data type that's internal to Python. So you have to if you want to print out every item in that sequence, you have to tell it, hey Python, I know this is technically some object, but I want you to convert it to a list so I can see it. So that's what this list function does. So what I'm saying here is range 3, give me the first 3 numbers in the sequence. Now convert it to a list so that I can print it out and then print it. So if I do that, I'll get 0, 1, 2, like I would expect. And then you can also print this as a for loop. So if instead of doing one, the range 0, 1, or range 3, I wanted to actually reference the numbers, this would give me this for loop would give me the equivalent numbers. So for I in range list, I would get 0, 1, 2. And again, I is referencing each item in that list. Questions? Yeah. Certainly. So range is a function in Python that generates a kind of weird internal data type that holds a sequence of numbers between that sequence of numbers starts either at 0 or at the low point that you give it. And it ends at 1 below the high point that you give it. So if you only have one argument in the range function, it will do 0, 1, 2. It'll do 0, 1, 2, or 0, 1 up to whatever 1 minus the argument is. Essentially, it generates a sequence of numbers for you. That kind of, yeah.
I guess instead of typing the 0, 1, 2, you can just put range 3, right?
You could do that, absolutely. And we will see that, we will see that in for loops in a minute. Any other questions? Yeah. Yeah. Yes.
It would start at 2, but it never reaches 5.
Right, because this is something that's internal to how Python works. The high value is 1 above the top value you want. And so again, this has to do with how list indexing works, and it's a weird feature of Python. But just remember that the top value is 1 more than the last value you want. And the reason for that really is because more often than not, range is used for list indexing. And so because lists in Python start at item 0 instead of item 1, usually if you do like if I do like for I in range 3 and then index my print list item of I, that will give me 0, 1, 2, which will get, if there's 3 items in the list, and we'll see this in an example later on, but.
So if you do range 3, 11, 2, what would it print?
So 3.
Yeah, so you have range 3, 10, 2, or if you do range 3, 11, 2.
That should actually give me the same thing.
Yes, so because it doesn't go above 11, so it would not print 11. If you would do 12, it would print 11.
But again, that's because of the step size there. Yeah. If I did range 2, 6, I'd get 2, 3, 4, 5. It's a very weird thing with Python, and this is true of a lot of languages. Yes.
So then for the third one.
Yeah.
Why didn't you do like 2, 3, 10, so that's 3, 10, 2, 7?
This is because of the order in which the function requires that you put things. So the range function accepts a maximum of 3 inputs, and those inputs are the place to start, the one above the top place to end, and then how many numbers you want to skip in between. So you can't, if you switch those orders, then if you switch the order of those numbers, you'll get a different result, because Python will think, well, wait a minute, that 2 is now the lowest number I want, and then 10 is a step. It'll get very confused. So we'll cover functions a little bit later, but essentially the numbers have to come in that order. The place to start, the place to end, and how many numbers you want to skip in between. If you only give it 1, I'm sorry. Okay. So, like I said, range can also be told where to start and where to end its sequence. And you can create a sequence with step sizes too. So if we print those out, it'll give us 1, 2, 3, because I told it to start at 1 and end at 4. And 1, 3, 5, 7, 9 here. I said start at 1, end at 10, and skip every other number. That'll print out 1, 3, 5, 7, 9. Yeah.
One comment to the red. The first number is inclusive. The end number is exclusive. And that the third one is step. So meaning that if you want to print 1, 2, 3, you need to write 1, 4. So inclusive, exclusive, and then step. So Python is defined like that.
Yep. So now going back to your point before, let's see how this works in a for loop, because range is nice and all, but more often than not, you're gonna use it in a for loop, and you're gonna use it in a for loop. And so if I want to print out the first 10 numbers from 0 to 9, I can type for I in range 10, print I. And what this will do is print out the first, and it'll iterate through that sequence that range generates and print out the first 10 numbers. Again, starting at 0, ending at 1, ending at 1 minus the top number. Okay, so here's a quick exercise. So using the range function, write a for loop that uses range to print the first 3 odd numbers. So I'll give you all a few minutes to go through that exercise. Give it a try on your own, and after in a few minutes, I'll show you all the solution. Indent, that's a very good point. I'll bring that up. Indenting is very important. If you don't indent it, it'll give you an error message, and that's very important in Python. You have to indent it. You absolutely have to indent the code block. So that's a good point. I'll bring that up. Okay, so I'm going to go ahead and show the solution for this. So in order to get the first 3 odd numbers, what I would do is do for I in range 0, no, 1, 5, 2. Actually, that's incorrect. I would do for I in 1 to 6. So this is the way to get the first 3 odd numbers. Now, the reason it's like this is because, again, when you call to the range function, the first element you give to it is the place you want to start. The second item is the one above the last item you want, and the last item is the amount of numbers to skip in between. So when I first did this, I forgot that this had to be 1 above the top number, so I printed 1, 5, 2. And because 5 is not going to be included in that list, it will only print out 1, 3. So I had to remember, wait a minute, I want one above 5, so that it'll actually give me all 3 numbers, and then I get 1, 3, 5. So. Yes,
What happens if I write I+1 under print statement?
oh, so if you do I+1,
I mean, under the print statement.
so you mean like this?
Yes.
It won't do anything. It will, so this will not, so because you're not assigning anything here, you won't actually be changing the value of I here. If you, this is only adding 1 to I in this line of code. It's not actually changing the value of I. And if I wanted to change the value of I, I'd have to do I equals I+1. And then this would, don't do this because this would really confuse Python. Because all of a sudden, because this iterator this I value is designed to do 1, 3, 5. But if I change the value here, watch what will happen. Oh wait, why did it not do that? That's weird. Huh? So like this?
Yeah.
Oh yeah, that'll get, so what that will do is so I is still generating 1, 3, 5, but if you do I+1, print I+1, you'll get the value of I+1. Why the I update didn't work, I don't know. It should have, but I don't know. Okay, so that was the first bit about for loops. That was a bit about for loops and the range function. So now we're going to look a little bit more at for loops and using for loops to go through items in a list or items in a string. So given this for loop here, how many times do you think the body of the loop is going to be executed? So how many times do you think, so if I do word equals oxygen, and then I do 4 letter in word, print letter, how many times do you think that print letter, how many letters do you think I'm going to get printed out?
6.
Correct. Good. And we can see that right here. If I loop through if I do word equals oxygen as a string, and then I do 4 letter in word, print letter, the for loop will print out every letter in that word. So it will treat a string a bit like a list of characters. So that way I can get each individual letter out of a string if I want, or each individual item out of a string. Are there any questions on anything with for loops or range so far? Yeah.
So I'll add a bit, when you're doing for loops, it's important that you're indenting anything that you want in the for loop. Anything that's not indented, will not be counted in that for loop, and it'll just run once. And the colon as well. So that format is pretty standard, and it'll actually give you an error of like expecting a colon. So that's where it would go after the range, or the parentheses.
Exactly. That's a really good point. So one thing about this syntax here is that the format always has to be for iterator in collection or something or whatever I'm trying to loop through, and then I have to have that colon after the end of it. What a colon does in Python is it says, okay, starting here, there's going to be an indented block of code. So after that, I have to do. So the very next line of code has to be indented here. So because this colon says, okay, I'm expecting the next line to be indented so that I know that this is the body of the loop that I'm going to be running over and over and over again. So if I forget that colon, I should get a syntax error. And if I try to run that, I do. Now Python is usually pretty good about catching things like this. If I try and do a for loop without a colon, it'll say, hey, wait a minute. You're supposed to have a colon here at the end of this. Now, if I tried to print letter but I forgot to indent. This will either give me an error, this should give me an error because letter is only defined within that loop. There's no such thing as letter outside of that for loop. So this should give me an error saying, wait a minute, letter doesn't exist. And instead what it does is give me an indentation error saying, hey, wait a minute. I know that you wanted to print letter, but didn't you really mean for that to be part of a for loop? So sometimes Python is pretty good about reading your code and checking and giving you suggestions about what you actually meant. So yes, in this case, I wanted it to be indented, so I have to indent by 1 tab, and now it works again. So this is very important. So with Python specifically, indentation is very important. If you don't indent your code correctly, you're gonna get errors. So keep that in mind. So the next point is nested loops. So you can actually do loops over and over and over again. You can actually do loops within loops. So for example, if I wanted to do for I in range 1 to 10, and then for each item in that, I wanted to do for j in range 10 to 20, I could do a nested loop like that. Now, what this will do is, if you do this, you'll loop over the numbers 10 to 20 every time you complete one iteration of the outer loop. So you can kind of think of it as looking like this. And here, the outer loop starts at I equals 0, or no, at I equals 1 in this case. That's a mistake I needed to correct. I'm sorry for that. So the outer loop, I equals 1. Then inner loop, J will go 10, 11, 12, 13, 14, 15, 16, all the way up to 19. And then the outer loop will start all over again. So outer loop, I equals 2. Inner loop, J goes through all of its numbers. And then on and on and on until both loops are complete. So this is very useful if you have multiple lists to work with at once, or if you have a multi-dimensional data set. So if you have a big table of data and you have to go through both rows and columns, this is one way of doing that. So for example, if I print for I in range 4, and then for j, and then in the inner loop I print for j in range 3, this should give you this will give a little bit of a clearer idea of how these loops work. What this will do is it'll start by printing the first value of the outer loop. And then that value of the outer loop will stay the same as we go through all of the values of the inner loop. And then the outer loop will start all over again. And it'll update the value to 1. And then it'll do all values in the inner loop again. So outer loop is 0, inner loop goes 0, 1, 2. Then the outer loop goes to 1. The inner loop goes 0, 1, 2 over again. And so on and so forth until both loops are complete. And this is useful because you can actually compute some slightly more complicated functions like sum product. And these are a feature of spreadsheets like Excel. So we can implement that using for loops here. So for example, if I have 2 lists, list A has 1, 2, 3, 4, 5, and list B equals 2, 4, 6, 8, 10, and then sum product is 0, and then I start with sum product equals 0, I can loop over all elements in the first list, and then for each element in that list, I can update the sum product here. So I'm going a little bit fast on this because this is a bit of an advanced topic, but I wanted to make sure that I mentioned that you can do nested loops. So you can do loops of loops. So that's going to be it for loops. Are there any questions on any of this so far?
If you can comment a little bit about how the loops within loops is helpful. I'm just trying to get to application.
Certainly. So imagine that you have a table of data with rows and columns of data. Let's say you have weights let's say you have what's a good example? Temperatures on the rows, and you have days in the columns. So you have times in the rows, days on the column. So you have for every day, you have a set of samples for you at each time. What a loop of loops would do is allow you to say, okay, I want to go through all of the rows, and then within each row, I want to go through each of the rows. And then within each of those rows, I then want to extract each column member. And actually, I'm sorry, I need to reverse that.
So the generalization of that is that when you have a matrix of like data, so instead of just 2 lists, if you have a matrix of data, you want to make sure that you're going through every row and you're going through every column, and that nested for loops will do that for you.
So if I wanted the average temperature at 8 o'clock in the morning.
Right.
I could do a for loop to be able to to take out the time of day.
Right.
And look at it across, instead of looking at it across long ways, looking at it across.
Or like, I guess if you want like the average temperature for all of the days for like, I guess over like a week or something. So it just kind of like collects all of that data, or like prints that out in the same space. I don't think of what else. Is it? For matrix calculation.
Okay, we can keep going.
Yeah. Well, matrix multiplication is a good example of that. You have 2 matrices, or you've got 2 matrices, and you want to go through each element of that list and then multiply the 2 together. You kind of have to have 2 loops for that.
Well, because I guess the other thing too is that the i's and the j's you can imagine as like x, y values. So if you're like calculating like if there's a pixel at like this particular like space, then like you'll be able to go through the whole space as opposed to just one row or just one column of that area. Yeah.
And then the responses. You go to both persons. And it goes to all the responses.
For that one person.
So the one person always
Yeah.
comes, person 2, person 3, person
Yeah,
4.
go with 5. Yeah, that makes sense. That makes sense.
Any other questions?
Yeah.
Okay. In that case, we're going to go on to the next topic. So the next topic is decision making. So one of the things that you'll want to do a lot with Python is you'll want to make decisions. You want to make decisions to tell your code to do different things depending on a value of a variable. So in order to get started on this, let's do a little bit of background. Let's get a little bit of background here. So if I ask for it, so this input function will allow me to type in a value from the user. And then if I want to actually, you know what? No, let's not do that. Sorry. So to get started, remember back to session 1 where we talked a little bit about assignment and comparison operators. If I try to print out, so there are 2 specific types of values in Python called Boolean values. These are essentially true or false values. So this is where you try to compare 2 different things. So for example, if I say print 2 equals 2, this will say, hey Python, is 2 equal to 2? That double equals is a comparison operator. And what that does is it says, okay, compare what's on the right to what's on the left and tell me if that comparison is true or not. So in this case, print 2 equals 2 is true because 2 is equal to 2. Now, if I say print 50 divided by 2, is that less than 24? The answer should be no. So that should be false because 50 divided by 2 is 25. So if I print those 2 out, I'll get true for the first one and false for the second one. We'll want those Boolean values because those are going to be really important when we go into if statements. So when it comes to if statements are how you make decisions in Python code. So in general, an if statement has the syntax: if condition is true, then action is then an action that you put in code in an indented block gets executed. So for example, if I finish the new Netflix series, then I will turn off the television. So there's a number of different conditional operators within Python, and the general ones are greater than, less than, greater than or equal to, less than or equal to. And most of these will look pretty similar to if you had, if you, from maybe your math class, you see the right arrow symbol is greater than, the left arrow symbol is, or the right is greater than, the left is less than. And then because underlines don't really work in code, you have the right arrow with an equal sign means greater than or equal to. Left arrow and equal sign means less than or equal to. The two that are a little bit strange are the double equals and the apostrophe equals, and the exclamation point equals. Double equals means basically says, okay, is what's on the left hand of the double equals the same as what's on the right? And then the exclamation point equals says the opposite. Is what's on the right of my exclamation point equals not the same as what's on the right. So in Python, we can ask Python to take different actions depending on a condition with that if statement. And an if statement usually has three parts. It has an if statement at first, then something called elif, which means, okay, the first condition I tried isn't true, so I'm not going to execute that first block. But here's another thing, maybe I can try that. Is that true? If that's true, then I'll execute that. And then the last one is an else block. This else block says, okay, none of the things I tried above are true, so what do I do otherwise? So for example, if I haven't completed the Netflix series, and have I finished studying for the night? If I haven't completed the Netflix series, then I don't turn off the TV. If I haven't finished studying for the night, then I shouldn't close the book. So what do I do otherwise? Then, well, then you can say, well, get back to studying or something like that. So the order of the statements is always if, elif, else. And those are your first condition, your second condition, and then what you do in case none of those are true. So as an example, let's say that I have a recipe that I'm working on, and that recipe calls for a sweetener, but it gives me some options in terms of that sweetener. Let's say that it says I need a sweetener, but if I have sugar, then I should add 3 tablespoons of sugar. But the recipe also says if you don't have sugar, then you can also use 1.5 tablespoons of stevia instead. And if you have none of those, then you want to make the dish less spicy. So cut the amount of red pepper in half. So this is an example of how you can do if, elif, else. Yes.
Are you limited to one elif?
No, that's a very good point. You can have as many elifs as you want. So if the recipe gave me an option for sugar or honey or stevia or I don't know, palm sugar, then I could have then I could have if sugar, then elif stevia, elif palm sugar, elif honey, and you can have as many of those as you want. And then else is really just it's kind of there to prevent errors and say, if I don't have any of those, what do I do? What do I do then? So we can kind of visualize this in a graph. So if let's say that I only have honey as a sweetener, but my recipe doesn't say that I can use honey. So if I have sugar, so the first thing I do is I go and say, okay, do I have sugar? Because the recipe first asks for sugar. If yes, then I go and add sugar, but I don't. So I have to go to this no block. So then I go to this elif box and I say, do I have stevia? Because that's the next thing it asks for. I don't have that either. So I can't add the 1.5 tablespoons of stevia. So I have to go to this else block. So I don't have any of those. And the recipe didn't say I could use honey. So in this case, I have to cut the amount of red pepper that I use in the recipe down by half. Yes?
So are these statements like prioritized in order they come?
Yes, they are.
The first match for.
Yeah, it's top to bottom. So the way that these if statements work is that first Python will check the if statement. If that's not true, it'll check the first elif. And then if that's not true, it'll go to the second elif. And then if that's not true, it'll go to the third elif. and on down until it gets to the else statement. The else statement will be the last thing will be the last condition it checks. So, yeah, question?
Program language I'm used to, I can figure out, so let's say I have 100 people, I could know how many are in each of those categories. Does Python, so I would know how many people, I know how many people had sugar, or know how many people went to stevia, and I would know the remaining else, how many were in that bucket. Does Python tell me that?
How many are in each category?
Like how many met each condition, like if I'm making a variable, for instance, and I wanna do it, it says, okay, we changed this many records from this command, and this many records from this command, and this many records from that command, and I'm trying to figure out, if I'm not gonna know, how am I gonna know where the people went, or?
So the base condition, so in basic Python, the answer is no, it won't tell you that, offhand. Now there are advanced libraries and functions that we can talk about after the boot camp, where you can kind of do that.
Okay, but in the basic one, it puts people in categories, but it doesn't tell you where it's doing.
No, you'd have to look at the list later on after, you'd have to look at your data set after the if statement. Questions? All right. So let's look at this in code. So consider that example above. So I set a variable sweetener that I have to equal honey. And then I say if sweetener, and then because the recipe I have says I can either use sugar or stevia, or I can cut down the amount of red pepper by half. I say if sweetener I have is equals sugar, then I add 3 tablespoons of sugar. If sweetener that I have equals stevia, then I add 1.5 tablespoons of stevia. Otherwise, I print, I don't have any sweeteners, one of the right ones, reduce the amount of red pepper called for by half. So if I execute this code, because the variable sweetener that I have is set to honey, and because this is the variable that is being checked against in the if statement, since sweetener that I have isn't equal to anything that's in either of these if statements, it'll check. The only condition that's going to come back true is this else statement. So this should print out, I don't have any sweeteners, reduce the red pepper called for by half. And you can see that it does. But if I were to change this from honey to sugar, now all of a sudden I have the sweetener, one of the sweeteners that the recipe calls for. So now this condition, this code should change. It should check this first statement, this first if statement, see that the variable sweetener I have is equal to sugar, and that is what I have. So it should print out this, add 3 tablespoons of sugar, and then exit the if statement. And now we can see that it does that. So this is an important tool to use to tell code to do different things based on what's going on in your code. So if certain conditions are true, then you can tell the code to do different things based on what those conditions are. And this sort of thing comes up a lot if you're doing data science or data analysis. You'll have to encode a lot of logical condition tests in your code. So one thing to keep in mind is that while the basic structure of an if statement is if, elif, else, you don't have to have the elif. If you only have one condition to test, then you can say, well, then you can omit the elif statement. So for example, if the recipe only said you can only either add sugar, or if you don't have sugar, then you have to do something else. Then what I could do is remove the elif statement and just do if and else. So in this example, so imagine that I wanted to test whether or not Candide was the current book that I had selected out of a library of my books. So if the book that I've currently got in my hand is Canterbury Tales, then when I go into the if statement, it'll check, is the book that I have Candide, and it'll see that the title is not Candide. So it will skip down to the else statement and say, I need to keep looking. So if I execute that, I need to keep looking. But if I go and pull out the right book now, and I pull out Candide, then all of a sudden it'll say, I found the book that I want. So this is used, so you don't have to have an elif statement if you only have one condition to test. And technically, you don't even necessarily need an else statement. The else statement is there. The else statement is usually there as a way of protecting yourself against errors. So I would always use an else statement if you can, but if you really don't care what the false condition is, then you can omit that too. Yes?
You say that, for instance, for that would be like the genre, and then when it says equal, and then that's like a specific item.
So you're saying this,
Like, no sweetener, like you had the sweetener, and then you had to specify that it was sugar, like, how's that?
so not quite. So the variable that you're checking in the if statement has to be a specific example. So but the name of the variable that I gave it is sort of the genre in this case. But in general, the value that the variable has to be equal to one of the conditions that you have in your if statement. So it has to, so the variable that you hold in book has to either be Candide or Canterbury Tales, or if it's anything else, it will just go to the else statement. So it's essentially checking it's checking to see, is what I have in my variable equal to one of the things that I know I can do? And if it's not, then I have to do something else. Any other questions? All right. So now let's do one last exercise before we wrap up this section. So in this exercise, write code in the box below here, which will take in a number and print out whether that number is positive, or negative. So I've already given you how to get the input from the user, which is this int input enter natural number here. What you need to do here is write the if statement that will print out whether that number is positive or negative. Yeah.
There's a logical here, number 0 doesn't belong.
I'm sorry?
Loophole, like only for number 0.
In this case, this is just an example. If it's 0, then it's neither positive nor negative, then you would just and that could be a good else condition. Yeah, that could be a good else condition.
Yeah, so as we're going through this is like a new function that we introduced to. So when you run it, the input will actually have like a block. And so you can enter in the number there. And that's what your array of code below is like, what's the interaction with that natural number, as opposed to defining it in the function. Okay.
Got it.
No, we use print number.
Somebody types in a number. Is there a way that you can? If it's not.
Yes. So it's a little bit different here, right? So,
I'm sorry.
so input always gives a string. And int conversion to integer, that's not what you can do, I'm not sure we have. So if you, so you will hit. So if you remove that instance first, just. Yeah. The two brackets. So you have a function called type, so if you enter line, so enter. You can do it. No space. So, no, if that. So if space, type. And then input like that. Equals. I think it's close. Integer. And so between closest to integer. So you test it as the value. So let me get 10 around it.
So you want to do this one, so that you have. So. Oh. But not
Fancy?
If you wanted to do it.
Yeah, so now that the errors are here, so now that I.
So this input will, so if you, it doesn't, it will not know what type of number it is. It really only knows the values of integer. So you put in, if you put in 0.1, it's gonna look at that and say, that's a floating point number, that's not an integer. I don't know the thing about that.
Oh, because of their. No.
No, it's that, function. That's taking whatever you put in the input and converting it. It's trying to-
Okay, no, I'm seeing what I'm doing wrong. Input number is string, it's always string, but we wasn't the type. I am actually not sure.
You want to use part in that case, because
There is a way that you do type.
no, what that will do is, so input will always return string. That's just a weird thing that Python knows. So if you want.
There are ways to test.
You want to use float, because that tends to be inclusive of integers too.
Yeah, so. Just forgot.
Yes, so like, so it'll.
Yeah, so there are ways, it's just like, no, now I'm used to it. Because input is always a string, so you cannot test if it's an integer. But if you do integer, then if it's not an integer, you will get something like 0 or error. So there are ways so in Python, if there's an error, you can do an exception. I think basically say stop here. And there's things you can do like that.
Yeah.
For now, just, that's more than that. It's not as easy as I thought.
Yes, it will be.
Doing a trick with that.
I want to fly the number here. Oh, I think it's on this first. Okay.
This is how it can run.
Okay, so I'm gonna quickly show the solution, and then we're gonna wrap up for this section, because we have to, because lunch starts at noon, and that's when we have to stop. So the solution to this is if input number is less than 0, print. Number greater than 0. Else. The number is 0. That's fine. So, so there. There. So what this will do is take my number, convert it to an integer, check whether it's less than 0 or greater than 0. And if it's neither of those, it'll say the number is 0. Yeah. So in the couple minutes we have before the end here, are there any other questions about for loops, if statements, anything we've covered in session 2 so far?
Thanks.
This is something that I can see it. After you outside. Okay.
So Markdown, you don't have to see the hashtag in front of it, and then Markdown is like a formatting. So like.
Pretty possible.
So like, I'm using these to make it look like it's closed, but if we take that out. Then it like will look like this, and it won't look this.
And it turns out, okay, that's.
Yeah, so it's all of the, so like this one here is in Markdown.
ELI.
Yeah, so like we have it formatted, so it's really nice. If you see it. So that's the difference between this and this.
So, okay, that's not-
The reason you correct.
Yeah. So if you wanted to ask about like, oh, like if I put in 0.1,
Which
I
one?
get this
It
here,
means that
you can write it as a
here,
comment.
And
Yeah.
you need to.
Yeah, so you have your.
Okay, it is noon, so I believe that means lunchtime. So when all of this information gets sent out, you will get both the code and the solutions. And there are a couple of extra things that I didn't get to in here. But for right now, we covered everything we will need for the next session. So I hope you all have a good lunch. We will see you at what? We'll see you at 1:30 after lunch.
Okay. Hi, everyone. We're gonna get started on session 3. I know that we don't have everyone quite back yet, so I'll say just like our general announcements to kind of stall for time. So we'll do session 3 and take a 15-minute break afterwards and then finish up with session 4. For those that are going through it, I mentioned a little bit before the lunch break that we'll be sending out the recordings of each of the sessions along with the solutions for each of the notebooks. So if there's any point where you're like, there's too many things happening, we'll send those at the end, probably in the next day or so. And then for our online viewers, we can't provide like hands-on support, but if you have any questions, put them in chat and Alex will either answer them or bring them up to the class. And if you have any questions in person, either for technical assistance or for questions about the lecture, let us know and then we'll address them. So without further ado, here's Jose with session 3.
Okay, thank you, Wesley. Hello, everybody. My name's Jose. Yeah, I'll be taking you in session 3, which is functions and errors and exceptions. If you are in this directory space, please pick part 1. So that'd be functions sessions 3, and then we'll go to errors and exceptions afterwards. Okay, so we're gonna use 2 notebooks in this session. The first one is gonna be about functions. Okay, so I'm gonna get started with that. If anybody needs help, raise your hand. You can go ahead and interrupt me. I'm okay with that. Just let me know. Okay. So first of all, we're gonna start with these lines of code right here. Okay. In these lines of code, I'm trying to convert right from Celsius, from Fahrenheit to Celsius, right? And what I'm trying to do is use the actual mathematical formula again and again and again. What is the problem with these three lines of code here? Anybody tell me when they look at these 3 lines? There's an error in there in the formula. Let me know what it is once you catch it. Okay, first hint is in the 3rd line. There's a mistake there compared to the other 2 lines. Okay.
It's 9 divided by 5 instead of 5.
Yeah, it's 9/5 instead of 5/9, right? So if I were to run this cell by itself, right? All the first 2 would be correct, but the 3rd one would actually be wrong. Okay, so we don't want this to happen to us, right? We want to be able to have code be reproducible and to repeat code without making mistakes. And that is what functions let us do. They let us package code and repeat it without having to copy paste the code again and again. Okay, so in terms of functions, we've already dealt with a couple of them, right? And we have built-in functions that come pre-packaged with Python already, and we have user-defined functions. In this section, we'll learn how to make user-defined ones, but these cells give us an idea of how to run a few of the ones we've seen, right? We've seen the print. That prints whatever string or whatever collection of strings I have in there. We have the for loop, right? That allows us to put the print and print multiple things in a list. And these should be familiar from the first 2 sessions. And then lastly, we have the type function that tells us the type of any input that I put to it, right? So in this case, the type of 5 is an integer. Okay, so these are user defined functions, right? I don't make any changes to them. Bless you. But we can also make our own, okay? So this is how we make our own function, okay? I'm gonna scroll down to where it says defining a function. I know there's a few cells in between there for you to read. But in defining a function, this is the general structure to it. I put dev at the beginning, right? Definition, and then the name of the function, and in parentheses, whatever parameters I want for input. So for example, if I were to define the print function, I would say def print and then a variable that represents whatever I put in, right? Is that clear there? How that looks? Okay. After that, right? We put in the body of the function whatever I want to do with those new parameters. Okay, and I'll give you actual examples to them instead of these abstract stuff. Okay, so in this first one, right, this function is called adding 10 to variable. And we don't need to add anything to this. This already runs, right? For whatever n I put in, I'm gonna add 10 to that n. Okay, and then I want to print the result. Okay, so does that make sense to everybody what that function does and how it's structured? Okay, so remember here, the colon at the end, same thing as the for, right? Definition, the name, and then the colon at the end, and then to indent, right? Those indents are necessary. Use tab to indent, not spaces, right? So we make sure that formatting stays stable. So if we run this cell block, right, it should run no problem. And if we add 10 to 5, we should get 15. Okay. Everybody clear there? We good? Okay. So once we move there, we can actually add more than one parameter. So the next one is to add two numbers, right? So same concept, definition, add two numbers. I'm being very descriptive with the names of the functions, right? So we can keep track of them. A and B, and the result is gonna be A plus B, and then I print the result. Okay, so go ahead and run that cell as well. And the next one, we should do 10 plus 23. Okay, so that's 33 there. It's all running well. Okay, any questions till there of defining a function? Okay. Oh, good. Yes.
I will say, so like, we've seen before for the for loops, and for if statements, they have to have the colon at the end of the statement. And for functions as well.
Yeah. Remember the colon there, and remember the indents as well, okay, formatting mark. Okay. No questions online, no, we good?
No, one remark, if you change something in that function, you have to rerun it, otherwise no one will not pick up the change.
Yeah, so for example, if for this one I eliminate this, right, I need to rerun that cell to change what that function does, okay? And if I run it again, in this case, result should be A, so it'll just give us 10, right? But that's an important point that I am able to change them, but I need to rerun the code. I need to. There we go. You must rerun the code. Okay, now for the next 1 or 2 minutes, I'm gonna leave you exercise 1, right? It's the same structure as the one we just saw, but instead of summing them, I want you to multiply two numbers, okay? So take A and B as your inputs and change the result to be a multiplication instead of a plus, okay? You have any questions, please let us know. If you got it, you can just give it thumbs up. If you don't, thumbs down. Okay, so most of y'all have got it, so I'm gonna write the solution there, right? I start with my dev. Then I put the name of the function, in this case, multiply two numbers. A and B are my parameters. And then afterwards, I'm gonna go result equals A plus B. No, A times B. Right, using the operator to multiply, and then I'm gonna print out my result. Okay, and then we go ahead and run it, should be okay, and then to try it out, right? I can just write it down here. Apply to number. And then potential. Okay. There we go. Any questions for that one? All good? Also, I know we may be kind of low from lunch. That's okay. Okay, take it easy. I know lunch hits hard. We couldn't catch a nap today, but works. So just let me know if there's any questions there. But okay, so moving on from that one. Now that we have a basic example on how functions and definitions work, we're gonna move to doing the same exact transformation we were doing before, right? Going from Fahrenheit to Celsius, but now in a function format, okay? So as a reminder, the formula is Fahrenheit minus 32 times 5 nines, okay? So I actually encoded that one for you, you don't have to make it. The definition is Fahrenheit to Celsius, right? And I put the formula in, but this is a bigger example, and it's an actual good example for how to make a function, is to not reproduce your code. So you should be able to run both of them, run the definition, as well as run the example with 41 Fahrenheit, and it should give you 5 Celsius, okay? So once you have that, also to this, you can add, for example, print the value and the C, right? To print everything together. The thing about functions is that I can join a lot of code together in a single go, right? So I can make the calculation and I can also print out the nice statement. Your temperature is, right? Well, I can do that here. Any questions there with bigger functions? Okay, and we'll keep adding to them as we go. So make sure that you're understanding as we go. So now I want you to grab the exact same code that we did for Fahrenheit to Celsius. But now we're gonna make a function that goes from Celsius to Kelvin. Okay, so adding to the Celsius temperature, the value, and you have the formula there, which is 273.15. And you should be able to make that function Celsius to Kelvin. Okay. I'm gonna give you about 1-2 minutes there, 2 minutes. No problem.
I'm gonna grab the exercise then.
So don't keep your questions to yourself, right? We all learn if you ask, and we're gonna keep composing bigger functions, so please ask now that we're talking about these building blocks that are important. Good. Perfect. I'm gonna start writing the example there, so same thing, def Celsius to Kelvin, right? I'm gonna put the input variable as temp C, which is the Celsius temperature, remember the colon. And then the indent, I'm gonna go temp Kelvin equals temp Celsius plus 273.15. And we go ahead and print temp K, okay? Let me run an example here, so. Kelvin and. Now we have, there we go, now we have our Celsius to Kelvin function working. Any questions there with how it's written, any formatting that went wrong on your side? Okay. Okay, pretty straightforward, right? Okay, so. What we've been doing till now is printing a result, right? So you see there at the end, I'm saying print the result of what I'm giving. But functions actually work with returns, okay? So the same way you have a function in math that returns something, right? When you put f of x equals y, it returns you a value after you put an input down. The same thing happens with functions in Python as well. So if you run our current Fahrenheit to Celsius function and you try to use it inside of a print statement right now, you'll see that you get the result and then a none. Right? You get the result of your Fahrenheit to Celsius, that's a correct result. Fahrenheit to Celsius, when you go 32, should be 0. But this, it's inputting none, right? Because there's no command to return anything from the function. So it says, oh, that function is just there. It did something, but I don't know what result it gave me. Okay, so that's the difference between printing and returns. Okay, we'll see examples of how return statements work as well. Right, so this is the value that it returns. So in case we want to reuse that function or use that function somewhere else, right, inside another function, we need to, instead of print Celsius, we put return Celsius. Okay. So that's the example for that Fahrenheit to Celsius one. And now you see that once I run this definition, I can run this print statement and now we get the actual result we wanted, which is the freezing point of water is 0 Celsius. Okay? Any questions there? Using returns versus prints. Okay. Right now it's more nomenclature than anything, but once we go in the few examples afterwards, we'll see that it changes what the results of what we're up to, okay? So now, we're gonna do the same thing that I just did, which is apply a return to Fahrenheit to Celsius. You're gonna apply a return to Celsius to Kelvin. So you can take, yes?
Can we not write the return where we define what Celsius is itself, like in that line itself?
Right here?
Yeah, before.
You could, but it's easier to see, right? Okay. You don't wanna have all the, because if you get longer functions, it's gonna end up being more steps than just one step.
Okay.
Right.
When I tried it over here, it says the syntax is invalid.
This one?
Yeah, when I write the like return before, like while I was defining Celsius itself,
Okay.
when I write return before that, it says the syntax is invalid.
Okay, then just keep it separate.
Okay.
Okay, yeah. Okay, know how that exercise is going.
Just return. So you can do return. Or you can do return instead, and those will both work, just not in the same space. Yeah. So whenever you're having a print for the return, you just can't have a equal sign. So you can print for the or you can print X is my term.
Remember, you don't have to type out your whole function again, you can just paste it from where you had it. And go ahead and change that line to a return instead of a print. Oh, good, thumbs up if we got it, we got the return working, okay. Thumbs up, perfect, so let me write it out, right, it should be the same function that we had. This Celsius to Kelvin one. I'm gonna go ahead and change that print temp K. To a return temp K, okay? Okay. So now we should be able to run this one, and we should be able to run this one as well, right? That's a Celsius to Kelvin, and our function should work inside that print function. Right? So this is. And I'm actually gonna do this exercise with you, I'm not gonna expect you to do it by yourself. So here we're trying to put a function inside a function. And this is the important part as well with functions, is that we're able to package code and reuse it inside other future code that is bigger, right? We keep calling other functions. So we have a Fahrenheit to Celsius function and a Celsius to Kelvin function. Now, if I wanted to make a Fahrenheit to Kelvin function, would I have to write the whole equation? Or could I just compose it to functions I already have, right? Does that make sense? Okay, instead of writing a whole new formula, so now we go, and this is where we're gonna go to exercise 4 there. And you see that we define a Fahrenheit to Kelvin function. We have a Fahrenheit to Celsius one, right? And I'm gonna take this and I'm gonna put temp K. So temp K is gonna be equal to what? What goes there? It's the other function that we made. Which one? Yeah, a lot of whispers. No answers. Huh? What's that? Yes, we feed temp C to our function, right? So we go ahead and put the Celsius to Kelvin function. And we feed the temp C. Okay? Alright, so we see that this is composing our two functions into one. Alright, we go Fahrenheit to Celsius, with the temperature in Fahrenheit goes to Celsius, and then the Celsius one goes to Kelvin. Okay, and we use both of our functions back to back, and then we return temp K. Alright, we can go ahead and hit and run it. And we can also run an example, so we can see that we did it correctly. Goes well. I'm gonna go Fahrenheit to Celsius, then to Kelvin with 0. That makes sense. Yeah. Any questions there with composing the two functions? All good? Okay. Okay. So let's keep going. So now that we know how functions work, right? We're gonna talk about the variables within those functions, right? So there's two things that are important. Variables have scopes. That means they can be used in particular places in your code. Okay? And we have local variables versus global variables. Okay, and we'll see examples of both of these. Okay, so let's look at our last function. Our last function used the variables temp F, temp C, and temp K. All of those variables are local variables. That means they can only be accessed inside our function block. I cannot call them again. So for example, this next block, if I were to print temp K, this gives me an error because there is no temp K variable that is global to my code. Okay? That makes sense. Okay? Yeah, this is more theoretical, but it's important to know what we're getting into. So if I wanted to reuse a variable, I would have to define it outside of a for loop or outside of a function, and that would be here. So for example, I'm saying Kelvin temperature is equals to that number, therefore I can print that variable because it exists outside of my function. I see confused faces. Okay. No questions because we don't know what to ask, or just confused because it doesn't make sense?
Don't know what to ask.
Don't know what to ask? Okay, okay, all good. So let's say, for example, let's go back to this example. So I have this code right here, right? So if I were to, outside this function, print temp C, for example, would it print anything out? No, because temp C doesn't exist. Unless it's inside that function. That's why we have the index, keep our code nice and organized, but it's also a real distinction that Python makes. That's a local variable, right? So I would have to define a variable outside. That make it a little bit clearer? Maybe, yes.
So for that, for like the block of progress before that.
Yeah.
You have like the functions, the two functions.
Oh,
Both
this?
those functions have to be defined before you can.
Yes, so for this to work, both of these functions have to be defined before we compose them, right? Okay, great question, by the way. It's important if you're composing, also, quick thing about Jupyter notebooks, right? I can run my cells in disorder and it keeps track of what is run. On a normal Python code, that's all one, that's not gonna happen. It's gonna go in a sequence down, but in Jupyter, I can go ahead and run whatever cell I want, right? And we keep track of that with the numbers on the side. Right, 23 means I run that before the 24. That makes sense. Okay. Any other questions there? Yes?
I will say clarification, when the reason that there are local variables and global variables is that we're already very conscious of if we're changing the value of a variable, it changes the value, like everywhere, right? So like, for example, what we were talking about in session 1, where like if we set weight to equal 60, then it's gonna be 60 everywhere unless I change it again. So what the global variables and the local variables are avoiding is if I want to change temp C as a global variable, that's going to impact how it works in the function. And so we want to keep everything that's in the function just to the function so we know what's going to happen with it. And yeah.
Thank you.
I hope that helps.
Yeah, code can get long and messy. If we start adding variables that are not local to that function, we will start getting errors and you don't know where they are. Okay, so it's better to keep local variables local and the important stuff keep global. Okay, so okay, we were here right here. Okay, so now we're gonna go into section 4. So right now we've done numbers, right? Fahrenheit to Kelvin, Kelvin to Celsius, Celsius to Fahrenheit, right? But we don't only use numbers, right? Python also interacts with text. So let's see how we can make functions that interact with text. And it's mostly the same thing, right? But we're gonna revisit some things that we saw in the lists section before. So as we remember, the way to add something to a list is appending, right? Did we cover that? Okay, so we're gonna teach something new, okay? Don't worry about it. Yeah, so here I'm gonna add a block of code, okay? And for just a second, don't try to type or anything, just look up here while I cover this section. If I have a list, whatever list I want, right? So I'm gonna create a list and I'm just gonna put, I know I said I was gonna do not numbers, but for ease of myself, let's do numbers, okay? So if I have a list called my list, because remember, we don't wanna rewrite keywords, right? And list is a keyword. So if I make a list called my list and I wanna add something to that list, I'm gonna dot append whatever I wanna add to the list. In this case, I wanna add the number 4, right? And if I were to run this, I will get an error. Because what did I do?
When we're doing append, we want to use parentheses.
I agree, thank you. So when we do append, we wanna use parentheses instead of the brackets, right? So now if I go ahead and print my list again, right? I should get my new list with 1, 2, 3, and 4, okay? Dot append is always gonna add the new item at the end, okay? There are ways to change that. We'll cover the basic one today, okay? So I can add anything. I can dot append a string. I could dot append another number, right? I could dot append another list, okay? So anything we wanna add to the list, we can do it with dot append. Does that make sense there? And that's what we call a method of a list, okay? Method just means that it's something that works with this guy. It's basically a function that applies only to that thing, okay? That make sense? Do y'all try it out? Try to type it in. create a list and go ahead and try to data append something. Okay, this will be important because the next exercises all use data append. So it's important that we understand how it works. Try to data append another thing that's not a 4, try to do a 5 or a 6, so you understand how it works, right? So I'm gonna change this to another number there. Right, so 1, 2, 3, and 7. Also, what happened there when I ran the 7? Where did the 4 go? It just disappeared. But why? Cause what?
That was the last one. Or no,
Because you run the first line again.
Cause I ran the first line again. So I ran the first line again and it changed the list back to 1, 2, and 3. Okay? But if I had ran the data append in a separate block, it would have added the 7 after the 4. Okay? We all catch that? Perfect. It's important to know that once we append is not deleting the last one, it's adding to the last one. Okay? So. Hold on. Actually add a code like here so you can see how. So you can see how that works out there. If I add a 4 afterwards, right? And I don't rerun the top one, I should be able to get the 1, 2, 3, 7, and 4, right? It'll just keep appending to the list now that I'm not redefining my list.
The difficulty with this is if you like are running your code again and you run the same block over and over again, you end up with a lot of 4s at the end and you're like, why? They never reinstated the original like 1, 2, and 3.
Yeah.
So if you see that and you're like, why are there so many 4s? That's why.
Yeah.
Can
Question?
you append multiple numbers?
Yes, you can append more than one thing there, okay? Okay. Everybody good with the dot append work? Okay, so now let's look at the next function. You don't need to change anything on there, right? But this 3 strings list is just appending 3 strings to a list, okay? So let's go together through how this works. We have the definition of a function called 3 strings list, right? And the parameters, what I'm putting in is string 1, string 2, string 3, okay? Now, I create a list, it's empty. It's called my list, I just define it, it's an empty list. And I go ahead and I append string 1, I append string 2, and I append string 3. So what should the result be when I return at the end? What should the result be there? 3 strings inside the list, right? It should return my list with all the strings that I put in, right? Okay. So let's see this example right here. If you run the function, right, you should be able to run this list, right? I'm defining as 3 strings list, and I'm adding the strings English, Spanish, and French, and I'm printing my new list, okay? And this should be English, Spanish, and French. Okay. Question there. Good.
Why would somebody choose to do this instead of just creating lists?
Yes, so let's say that you need to feed in new parameters, like at some point, right? Or you're running a for loop and adding stuff as you go, then you'd want a function that is able to add stuff dynamically. It's not just, you're just not hard coding a list, right? 'Cause it's easier to just write a list, this is what is in there.
Yeah.
But if I wanna change it, let's say I'm creating statistics, like I'm creating the mean of a column, I wanna be able to append the mean back and back and back. Right, so I would create a function that creates a list and changes what's inside the list. Does that make sense? Yeah. So whenever we wanna create dynamic, like whenever we wanna change stuff continuously, functions are great for that. Right, if you know your values are not gonna change, use a list, right? It's easy, it's approachable, it's nice to do. But if you know things are gonna change, functions give you the flexibility to play with stuff, okay? Any questions with that 3 strings example? All good? Also, quick question there. What is this doing? New list equals this. Why am I doing this new list thing? What is that?
But it's variable.
Yeah, it's a variable, right? And what is being given to that variable? Okay, let's look at our function up here. There's a return my list, right? So whatever comes out of that function becomes this variable. Does that make sense? Little, okay, so let's look at it again. So if I have this function right here, right? Three strings list, I'm putting the function equal to this variable. So whatever my function returns is gonna become that variable, okay? Important distinction, I'm not just printing out the function. I'm putting the function equal to something. And that something is what I can use again and again and again, okay? That's the important thing, that's the same thing we did before with temp K and temp C, putting them equal to their functions, right? And reusing them, that's the way we do, okay? We put a variable equal to the function. Any questions there? Oh, I got one there. Yes,
What's the difference if you replace return as print?
yeah, so we can try it, go ahead. So we go ahead and print here instead of return, right? Print my list. And I'm gonna remember to run this code block again. Right, so I have that code block, let's run this again. I'm gonna print out none, because when I print new list, no value got returned into new list. Does that make sense? If there's no return, then that function didn't produce anything to pass into the variable. So that's why it prints out none. Okay, so that's why we use returns, to be able to use, it's the same concept we covered before with the printing, right? We need to use returns to be able to reuse. To be able to reuse the value of our functions. Okay, I'm gonna rerun this so we can get the correct value there, right? Let me see that, the none disappeared, okay? Because I'm not just printing an empty variable.
So you mean return is to make the value to be reused outside?
Yes,
Okay.
there we go, yeah. Yeah, return allows you to feed that value to something else.
So that means this definition become as a global definition.
Well, every function is global.
Oh,
Yeah.
okay.
Yeah, you can access every function where you are. Yes.
Question. The reason return print are different because can you see the next line new list? That line 3 string list is to call back to the function. The next line new list equals to 3 string list. Do you see the next line in cell 36? Yes. Here is you call back to the function. If you do not include anything here, you do not know whether you return the value or not. So if you want to reuse the value printed out from the function, this is how you call back to the function. And how this is why function is reused for several times. And you can make changes to this line to call back.
So every time if you define a function and you want to call the function, you have to return.
If the
Yes.
function asks for something, if the function is asking for print, you need to return that string. If the function is just for example, sometimes it don't need to, but it depends on the function, what the function performs. Okay.
Thank you.
Thank you. Everybody clear there? With the printing there, all good? Okay, so now we're gonna expand our function, right? We created a 3 strings list. I want you to add two numbers. Okay, so the same function we had, you can copy paste my function that I gave you, so let's go ahead and do that together. If I grab that 3 strings list. Right? We're gonna go ahead and change this and add 2 numbers. All right, I want to append 3 strings and 2 numbers to my list. Okay, let's see how that function comes together. I'm gonna give you about 2-3 minutes to work with that one. The format is the same. We're just appending 2 more things, a number 1 and a number 2. That's all. Give me a thumbs up if you got it. I'm getting there, okay? Right. So I'm sorry for online, I know I walk a lot, but hopefully you're catching what I'm doing with the mouse. Okay, I'm gonna start writing solution there, okay, so first thing we do is edit the parameters. All right, I'm gonna add a num1 and I'm gonna add a num2. And then I wanna append both of those, right, so I'm gonna go ahead and add 2 more lines. And change the variables I'm adding, I'm gonna append num1, I'm gonna append num2. Okay, and that should give us, I'm gonna rename it instead of 3 strings, I'm just gonna rename it 5 things lists. I think that's pretty descriptive. 5 things, okay? And it should run okay, but now we're gonna create a new code block and we're gonna try to call our 5 thing list. Okay. And as I said, it's gonna be 1 string that says hello. Another string that says an A. Another one that says a B. And then I'm gonna add 2 numbers. Okay, and then if I run it, right, it's my list of hello, A, B, 2, and 4. Okay? Everybody good there? You all got a function that outputs all 5 things together? Yes? Question?
And why do we have to put the num1 and num2 and the 5 things first before?
What do you mean?
Like, when you're in the function,
Yeah?
we have like 5 things, but like if you use append, and wouldn't that just automatically add it there?
Oh, you're talking about these 5 things up top?
Yeah.
No, so these are the parameters for the function, that's what the inputs. So let's say, for example, if I eliminate num2 from up there. Then that, there's no variable num2. I can't feed anything into it, right? This is just saying there's 5 things I'm adding to you and you can use them any way you want. I could print them, I could sum them together, I could multiply them, but these are the 5 things I'm giving you, right? It's not that top thing doesn't do anything for us in making a list or anything. We make a list in this step and then we fill it with this, right? This is doing nothing for our list. The top one is just creating the function call, okay? Great question, by the way. Because I know when we're working with lists, it can seem like we're repeating, but it's just because this example is a list. If it was a different type of example, what I take under advisement for next time, then it works in here, okay? Okay, so, but what happens if I switch these, right? What happens if I go hello, A, 2, and then a B? Right, because I said it was. Wait, and then sorry. Right, because what happens if I switch the 2 and the B? Should it still work or should it throw me an error? Because I said it was 3 strings and 2 numbers, right? It should throw.
But strings can be numbers.
They can, but not if we don't define them as something.
Okay.
Right, but in this case, if I run it, it will still run. Because I'm not specifying what they should be. I'm just giving them a random name. I could as well name them celery, carrots, and blah, 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 and the variables will output the same, right? So how do we specify? We'll specify by using these things, okay? These designations, where I put a variable name and then colon, the type of that variable tells me I need that to be a string. I need that to be a number. Okay, and if you're familiar with other programming languages, this is gonna look very familiar with you, okay? If you're not, it's okay, it's just, we use it as convention that I know string 1 has to be a string, I know num1 has to be an integer, right? And that way, I don't get confused when I'm reusing my functions. I'm like, oh, wait, Was that supposed to be a string or a number or a float or a Boolean value true or false? What is it? Okay. So now we're gonna actually run both of these, right? I gave you both of these together, but it's because I wanna play around with them instead of having us build them together. We'll build a future one where you define what it is, right? But if we run the add two variables, right, and this one, the first one will just add two variables together as we've done. But it's trying to add a string or a number, right? From experience on our last class, what happens when you add a string or a number? Huh?
It puts them together. It'll print like the string and
No, it should not sum, right? A string and a number don't sum together. Unless a string is an integer. Does that make sense? We'll see the example in a minute, but if if I go here, let's actually do it together. So if I go 2 plus and then hello, right? This is giving me an error, right? That's what should happen, right? So I created a function that adds a string and a number, and it should give us errors. Okay, I just don't want you to be afraid when errors start popping up left and right. I made it that way, okay? So don't worry about it. But when you add a string and a number, you're gonna get an error, right? And the other function that we're gonna run is called one of each list. It creates a list with one of each. Okay, a string and a number. Everybody good about what those two variables do? Okay, so now this is the example I wanted to get to. And it's trying to run these, right? So what happens if I put a number and a string together? I should get an error, right? Because you can't sum a number and a string. Okay, we see the same error pop up. Unsupported types. But if I do two numbers, right, for my list of one of each, it's a solid list that works out, all is good, life is happy. Okay. Any questions there? Yes.
you didn't specify like what is a string and what's a number, would it print two of them together?
It would print the two of them together if they were both strings or if they were both integers. Okay, the problem here is not the function. The problem here is the actual math of it, okay? For example, if I here there's no function involved. It's just an integer plus a string, we get an error. Like the problem itself is that you can't do that unless they're both numbers, right? In the case it's 2 plus 5, right? This is correct, or unless it's a string with another one. Each and out. Right? It joins them together, right? But unless the thing about it is that it's very confusing is that if I put a 5 inside the commas, it's gonna sum it, right? Because it's technically a string, but it's not a number. Okay? All good there. So if we see commas, what is it?
String.
That's right. Okay. And if we don't see commas, even if it's a number, it's an int, okay?
Apostrophes.
Apostrophes. Yeah, I call them commas. Arial commas. Okay. So we're good there with types and specifying types. Okay, so the important thing to remember here is that if I'm ever creating my own function, it's good to put what type I'm expecting. Even if you're the only one who's ever gonna read it, it's great to put it there, okay? Because then you may forget, you may come back to your code in 10 months and you're like, what was it trying to do? Right, so this helps us keep good documentation. Okay, and we'll talk about documentation more below. Okay. So now, after this new list, one of each, I'm gonna move to loops inside functions, okay? And here, I'm not trying to add more work to your plate, I will later, but here, I'm just trying to show this part of it, okay? So for a searching list for Spanish, remember before we made a list of English, Spanish, and French, right? So in this function, I'm gonna go through that list and try to find the index of Spanish. Okay? This is like going through an Excel file and trying to find the correct row. Okay? So it's the same case here. So I'm gonna go for each item in the range, right? If that item is Spanish, go ahead and return that item. Okay? I know it has multiple blocks in it, but it basically goes through our list, finds Spanish, and it returns the index of Spanish. Okay, does that make sense? What it does, even if the code doesn't make sense, right? Conceptually, we understand what that function is trying to do. So if I were to run this function and I were to run the next one, right, it should tell me Spanish is in 1. Why 1? It's in Spanish, the second one there. What is it doing? Yes, it starts with the 0 index, right? So English is number 0, Spanish is number 1, and French is number 2, right? So in this case, if I search the list for Spanish, it's gonna say Spanish is in number 1. Congrats, it's here, we found it, okay? Does that make sense? All good, how that function works, okay? Good, so now I want you to copy that function and make it search for French, okay, instead of Spanish. Don't write it from scratch, right? Just copy the function that you have here. And then go ahead and paste it in here and edit what you think will make it search for French instead of Spanish. Okay? Huh? I'll scroll up. You good? Yeah, just so much soon. Man, I don't know where I am there. Any questions online, Alex? Are we good there? No? Perfect. Okay. Good job. All good there? Anybody change the French? We found it? Yeah.
Can you explain again why it returns a number?
For this one?
Yeah.
Yeah. Okay, so actually, I'm sorry, Alex, I'm gonna write on the board. But, I won't have, so you don't have to type it in the chat, I'm pretty, this is good, so. The key for that is in the for, right? So we're saying for item in range, in this case, right, range n, but we said it's 3 things, so range 3, right? Range just means it's gonna go for item or each thing. Item, remember, is just a variable. It can be a thing. I can call it number, right? I can call it index. In this case, I call it item, but it's saying for each of the things in this thing, which are the numbers 0, 1, and 2. Go ahead and do something with this thing, right? So for each of the things, go ahead and search each of the things and then return me the thing. So if I went through numbers, it's gonna output them, right? Does that make sense there? So what's happening there is grabbing the 0 and it's going, okay, 0. Okay, so item 0 is English, not that one. Item 1 is Spanish, it is that one. So let me go to my next step, which is returning that one. That makes sense? Okay, so same way I called it for item, I can call it for number in range, for table in range, I can call it whatever I want, but in this case, we like to use item, a lot of people like to use I, a lot of people like to use n or number, right? Those are just conventions that we use, but any of them are valid. As we talked, like in the for loop. Does that answer your question? All good there? Okay. Anybody else? Any questions there? Also, what was the edit that got it to French? What did we do? Yeah, equal to French, right? So instead of checking for Spanish, we go ahead and we change the string to search for French, right? And if I were to make a new code block and I were to search list for French, I'm gonna change the number to search list for French, right? Let's put it in here. And I'm gonna go search list for French. And go, right? So I should run both of these again to make sure everything's run correctly. And now the output is a 2, right? As we expect, French is the number 0, 1, 2 is the number 2 in that list. Okay? Any questions there? All good. Yeah? Question.
I'm just, why did it stay the same for both of them?
Yeah, so the 3 there is just saying I have 3 things in that list, right? Cause we have to go through a range, right? So we go 0, 1, and 2, but if there were 4 things on the list, right? I wanna go through the numbers 0, 1, 2, and 3. And there's more things I wanna be able to keep on adding numbers. Okay, is that clear why the 3 is there in that function? Yeah, okay, perfect. Okay, so the last exercise for this section is actually, and you're gonna be very happy to know that the next session for me, the errors one, is mostly me talking. So if you dislike my voice, you're in tough luck. But if you wanna take a break from all the typing, you're gonna be okay. Okay, so this is the last exercise for this. I want you to grab the same big code that we had, the search list for Spanish or the search list for French that you made. And I want you to add a parameter here called the parameter called string, right? And I want that parameter to be the one we search for. So we can search for Spanish, we can search for French, we can search for English, right? I want to be able to change what I'm searching for with the function itself. Okay? That makes sense? I'm gonna actually put where the new parameter goes and then you change inside the function where it should go, right? Right. So you see, I changed the parameter, I added a 3rd one. So you just tell me where does that new variable go? Where does string go? Anybody got it as well? Yeah. Okay, good thinking. Okay, I'm gonna go ahead and change it here, so you can see what the solution for that was. Instead of searching for French, we're gonna change that to searching for string. Right? And so once we run this and we call our new function, right? Now we have 3 parameters. It says the list is gonna go through, it says the number of items in that list, and it says what I'm searching for. In this case, French. So if I were to call this function, it goes ahead and outputs 2, okay? I found the index for French. Everybody good there? Make sense? Good? Yeah? Okay. Okay, so the last section in the functions, part of it is testing and documenting. For this one, I don't want you to run any of the code. I'm actually just gonna talk you through what testing is, right, and documentation is. So all of what we've been doing today can be considered tests, right? It's little things that we try to see and check if it's going okay with our function, right? But it's important to try inputs that we know the answer to. And in research, this is critical, right? Many times we're trying to do new things and calculate new stuff that nobody's calculating before. But if you don't know what your function does or how it's supposed to output, then how do you know it's correct, right? So we put in inputs that we know the answer to. For example, in our search list for Spanish, we had a really short list. We knew Spanish was in there. So if we were to use that for a big Excel sheet, we know it's gonna find Spanish correctly because we did it once already, right? But that's a small test, small block test that we can measure for, okay? But we can also add things that make it tough for our test, and we keep complicating the test little by little. In this case, I created a list that has 2 Spanishes back to back. What do you think will happen if I run this list instead of our one that has only 1 Spanish? What do we think could happen? Huh? Error, maybe, okay. It will find both, okay. Anybody else? Good, so actually, if I run this one, it actually only finds one of them. Why? Anybody know why? What is that? It only looks for the first hit, because if I'm saying return, it's gonna return outside the function. Right, return marks the end. The function says, I did my job, I returned, I'm done. Why am I doing anything else? So to get both, I actually have to change and print out the indexes, so I get it, or I have to change the logic so that I keep on going even if I find it. Okay, so that's the important thing to take away from this is that I can change my tests to make it harder or less or harder or easier, right? To go ahead with it. Question there? Okay.
Why did return 2 if Spanish is at next 1 and 3?
Yeah.
Good question. Okay. So I go, so let me take the function that's correct, right? Search list for Spanish. And this is, there we go. So this one's right. Right. Oh, I had it here already. There we go. Okay. But I run it. My bad. Okay. But yeah, it's supposed to find the first one it sees and get out. Great catch, right? Okay, so if I want to output both, how would I do this, right? So I can change the return, so instead of returning, printing both. Because the print doesn't signal the end of my function. So now we get both 1 and 3, okay? And this is not ideal programming practice. We like our returns, but it's a nice distinction to have, and when I'm looking for multiple stuff, this is the way to do it, okay? Does that make sense? There, all good, question?
But we haven't defined the return value there, so it hasn't returned anything as none as well.
Yes, because I didn't put a, like, there's no equal to a variable, and I'm not printing that variable out, so there won't be any none. But good catch, so now that there's no return, if I say index, for example, I make a variable that says index of Spanish, right? And I print out that variable, print index of Spanish. This variable, as you will send, should be none, right? Because I didn't return anything. We'll see that that is indeed the case, right? Because there is, let me scroll up, right? Because there is no return case here. It's just printing out stuff. Correct. What you thought is what it was. Makes sense, right? Okay, everybody good there? I know this section we didn't do a lot of coding, but our brunt of coding is behind us. Yay. Okay, so any questions before I, yes,
Until my section.
until her section. But now the other important thing if we're making really big functions is to make them readable, not just for you, but for other people, collaborators, students, teachers, anybody else, okay? So let's look at these 2 functions. These 2 functions do the exact same thing. This one does exactly what we said before. Way less understandable, right? There's no name to it. I use I and N and LI. I use L instead of list. It's a whole mess. And it technically works perfectly. Okay, but it's not readable. And if I were to share this with somebody else, they'd be like, what were you trying to do? Like, what was the idea behind this? And the best idea is to use what we call documentation. So in addition to your string, and in addition to your actual code for the function, we can put what we call a doc string. And doc strings, when we talked about earlier, when we use the help function, doc strings are what comes out when you put help. Okay, that's what's talking to us. What's up with this function? So in this case, I'm saying the search list for Spanish finds the index and a list of items. This is an example of how it works, and it's all written down, nice and clear, right? And ideally, all your work will be like this. I promise it will not be, because it's not mine either. But if I had all the time in the world, I would do this for everything I have, right? And ideally, everybody would understand what I'm trying to do. And then every time they hit help, they get a really nice documentation of what I was thinking at the moment. Great idea, right? But if I had the time, it'd be amazing. And my supervisor would be really happy with my code instead of sending it back to me. It's funny because she's sitting in the back. So everybody good there with what doc strings are and what they do. Okay, so now I'm concluding with functions here. We're done, put a pin in it, okay? And we're gonna go to the error and exceptions one. And for that one, I have about 10 minutes so I'm just talking for that one. There's bonus exercises on this one if you want to try it on your own when we send you the solutions, right? But we're not gonna touch those now. So if you go to home again and you click errors and exceptions, right? This one should come up, right? That's not it. The session three acceptance ones come up. So let me scroll down, okay? And for this one, truly, I'm just gonna be talking about this one. So as we've seen, errors are a thing, right? They come up all the time and we gotta know how to read them. We gotta understand what they do. So for example, here, I have the same error that happened to us earlier, which is to try to sum a string and an integer, right? And it says, I cannot put these together, right? The only way to sum a string is to another string or an integer to another integer. So this is a common error we've seen. But what type of error is it? It's actually a type error. Okay? So each error has a name next to it. I'm glad the joke landed back there. That was good. Okay, so if I keep going with errors, right, we get what we call tracebacks. Now, tracebacks are that scary thing that appears at the end of our cell block. Right? It tells us where the error is, what the error is, where and what. Okay, so as we can see there, it's saying on line 2, you got an error, and that error is a type error. Okay, that's all that these tracebacks do. It's actually called traceback. You will see it up there, what it is, right? And you'll get this dashed line through it, and that is constant throughout the use of Jupyter notebooks. That's how errors come out, right? And in other systems, errors are very similar, and they're all tracebacks because they're just trying to trace where it happened, right? Everybody clear there with errors? Okay, so in addition to what they show us, right? There's a long-winded explanation here of what I'm saying, but tracebacks can also be way longer than we want them to be. So let's look at this example. So let's say I have, so I'm just writing exactly what's on there, but so you can see it step for step. So this call is calling a function, right? It's calling the function summation equation, which I'm gonna call s.eq, okay? When I call that function, which is this one, calls the function sum, okay? So it calls the function sum. And then inside the function sum is doing a word plus a number. Well, that can't be, because a word plus a number will never sum. So if I run this block, the error, oh, you're good. The error, we see the callback here that is saying, oh, the error was on line 8. Well, wait, no, it's on line 5. And then it's saying, hey, we cannot do this because we cannot sum a word with a number. So, right, the error is when we call the sum function, and you have to go to the sum function and get it fixed. Okay, so when we see really long tracebacks, we gotta see where the error happened. Right, it may not always be the first line that pops up the error. Okay, and that's important when we're working really complex code or with bigger functions. It may call an error on line 32, but the real error is in number 16, or it's back on number 8. Okay. Make sense? We good there? Okay, so that's the importance of tracebacks as we go. Okay, all good? Okay, and then. In addition to these types of errors that we talked about earlier, we also have other errors. And in this example, okay, there's already an error here that maybe we can catch with our eye. What do we think is missing here? In this for loop, there's something missing formatting wise that will not let it run. Huh? A colon, right? So if I were to run it without the colon, right, I would get a syntax error, right? And that's what we call the syntax error expected colon at the end of line 2. Okay, pretty simple. So that's the other type of error that's really common is syntax. And I will tell you the same. No, I won't tell you indexes because I'll assume they're back to back. But it does happen a lot with colons or commas or apostrophes. Okay. Let me just skip that one. The last one I want to talk to you about is name and identifier errors. So for example, let's look at this cell right here that says hello equals hello the string and world equals world the string. But when I called the string, I said world with a capital W instead of a lowercase w. So world uppercase W does not exist. So if I run this, it's gonna say error, name error, okay? Because world is not defined. Correct? Although it is, but it's just the other one, because they make a difference between capital and lowercase, right? So those are the 3 types of errors that are important to us right now, which are name, syntax. And what did I say the first one was? Huh? Hi, there we go. So those are the 3 types of errors that are really important when we're starting to learn Python, when we're starting to do stuff. They'll pop up a lot. It's okay. Red does not mean that I crashed the computer. It just means that the cell is not running, okay? So, any questions there with errors, these 3 types of errors, and how they work? All good? Okay, so actually I want to scroll to the bottom here where I have a list of a bunch of errors. Well, yeah, so these are a bunch of Python errors. Right, so there's a lot here, and we actually compiled a list for you just as reference. Right, in case you ever see an error pop that you're like, oh, it's not one of the big 3. Well, it can be any of a dozen or 100 types of errors, right? That are there, and it can mean that I just need to know what it is. And some of these are really rare. You most likely will never see them. But it's just good to have a list somewhere in case, you know, it happens. Okay. So that is it from there, 242. Yeah. That is it for me. Okay. Thank you so much. Marcelina will take over for session 4. We have a 15-minute break. So we'll see you back at 3 o'clock. Okay, thank you.
Starting a little bit early. Okay, hi, these. Switch over here. All right, so, I guess while there's like a couple of minutes left, are there any questions on like the previous sessions that we've had that you want to cover? Someone had asked if there's any way to kind of contact us after the workshop. We do have an email. It's support at, I'll type it here. Support at rcc.fsc.edu. And that's how you can reach us and just let us know that you have some questions about Python Bootcamp. And we'll help you out. I guess, yeah, so I know that this has been a very long day, so thank you all that have stayed, and thank you for the ones that have come in and out to participate. What we are gonna do, just in general, and I've said this, I think, at probably every beginning of the session, is that we'll have recordings of all of the sessions, and we'll send those out to anyone who's participated, or is marked as interested. and we'll send out the solutions as well. And I have both the Jupyter notebook for my session as well as some slides, and those will get sent out with the solutions. So if you don't see slides, that's like by design. So for session 4, I'm covering debugging, assertions, Jupyter features, and what to do moving forward with Python. So Jose went over errors and exceptions earlier, and debugging is not exactly the same as errors and exceptions, but we'll kind of walk through how to debug a program, how to do more preventative measures for making sure that we're catching the errors as they're happening instead of going, oh, there's an error, now I have to kind of find a way of catching it. So debugging is when you have an error in your code, but it's not going to give you an error, like the error output that Jose mentioned last session. It's more like, oh, the values for Fahrenheit and Celsius don't make sense as in terms of my output, or I'm getting a negative value when I'm asking for weight, which is like it's not what we're trying to get for the weight. So how do you debug your code? It's a little bit harder because there's not an exact like, oh, like this is the glaring error. You're just like, something's wrong in here and I have to figure it out. So we become little detectives. So the way that we start with the debugging process is we test with simplified data. So again, like for the Fahrenheit, Celsius, we know what 0 degrees Celsius and 100 degrees Celsius are supposed to be. And so we can double check to make sure that our equations are correct. There's standardized equations for converting from Fahrenheit to Celsius, and that's what it means by compare with an oracle, or the other thing you can do is compare with a test case where you know what the output is supposed to be. And if it doesn't reflect what you're getting, then you can go back and try and find where that is. For checking conservation laws kind of goes along with both of those, but physics is very big on like, you want to make sure that you're not losing any data as you're going through your program, or you're making sure you're adding like drag or something like that. The last bit is to visualize your data. Sometimes you can see it better on a graph, and we'll talk more about that when we move to intermediate Python. But sometimes that's a lot easier than looking at the numbers and going like, I'm pretty sure these are right. So as we're kind of debugging, we want to make it fail every time, because if we know that the output's incorrect, then we can kind of work backwards to see where it's failing. The part that like we see a lot in high performance computing is when when someone is testing code, sometimes it'll take like 30 minutes or an hour to run through all the code. And then just for it to end up with an error. So you want to make sure that you're trying to make it fail as fast as possible so you can troubleshoot as fast as possible. When we are debugging, we want to change one thing at a time, so that way you're not looking at like multiple different parameters that might be the cause of why you're failing. And as you're keeping track of what you've done, like the kind of like a scientific method of like, okay, this worked, this didn't, and we can go through that as we go through. So I feel like debugging comes in handy a lot when you're getting code that you haven't personally programmed, or you haven't maybe seen in a really long time. So when we're looking at code, we want to know what's going on and what the intended purpose of it is, right? And so sometimes we'll have helpful function or helpful comments in terms of what we're working with, and other times they'll be like, oh, there's patient data in list. I don't know what that means. I don't know what these units are for each of these lists. They don't look like the height of 70 inches or the weight of 1.8 grams, pounds. So it's something to keep note of as you're going through and debugging, is making sure you know what is happening here. So we'll start off with some lists, patient height, patient weight. We have a set of numbers and we have both of these lists that have 3 items in them. So as we're looking at it, we assume, or we can assume that the first value in both of these lists correspond to the same person. And so that way we can catch them by assigning them the same index. We see here that there's a calculate BMI function, and we can double check to make sure that this is the correct formula for BMI if we're manually calculating it. The patient number here is just 1. At this point, it's not super clear how this is relevant to it, but as we look, there's a for loop below here that says per patient with calculation function that has also a print statement that says patient I has BMI and then a calculation. So we're assuming that what the program is meant to do is look at each of the patients and provide the BMI according to this calculation up here. Right? Does that make sense? In terms of looking at code. So a lot of unknowns here, but sometimes you just kind of have to run with it, see if it's giving like the correct output or output that makes sense. And then we can kind of troubleshoot if there are errors as we go. So we will run this. We will click over here and run this. And the output that we get, is below here. So the output that we get is the patient 0, 1, and 2, their BMI equals 0.0002. But as you can see, each patient has the same BMI. But if we check back here on the patient height and weight data, they're all different. So it's either a freaky coincidence or something's wrong with our code. So, so the brute force way of debugging, and the way that you first start out is you just start kind of adding print statements to check what your inputs are and what your outputs are. So in the code that we have here, I wish that I could shrink the top part and fit it all here. So in this space, is there any where that we can check the weight and the height of each patient as it loops?
Into the GMI function, calculate BMI solution.
So yeah, so we can check it in the calculate BMI space. So we can check it over here where we're printing height, labeling what we're printing. Printing weight. But this can kind of get a little bit messy as we go through. So for example, when we run this here, we have the height and the weight, but we don't necessarily know what patient it's going to, right? So something that we can do is do it directly in the for loop. So that way we know both what the patient is and then the height and the weight that we're looking for. But we can't just copy and paste this over to the for loop because this is our local variables versus our global variables. So, what first we want to do is we want to make sure that we are specifying what the patient number is. That's I. And then the height and the weight. So what is the height in this for loop? So patient height. Patient height, and then we want it to be the I, so that it matches the patient. And then for weight, what is it?
For weight,
Yes, so patient weight of I. Alright, so now we have the patient, the height, the weight, but as we can see, the BMIs are still the same. So, is there anywhere in our for loop where we might not be calling height and weight correctly? And this is tricky, like this is definitely not something that just by looking at it, we can figure out. So,
By calling those function.
Hmm?
Patient number.
right. So there's a couple different ways to solve this, right? So the patient number here is not changing as we go through the for loop. So that means that it's only calculating patient number one's data as opposed to every single patient's number. So when we do this, we can just simply change patient number to I and delete patient number because it's not really doing anything. So that's one solution. And another solution that we have is instead to set patient number in the loop. And we can set patient number to I. And then we can maintain what it was before. So,
But you also can say print patient number, right?
right. So yeah, so if we set it here, then patient will then be patient number. Yeah, that's what you meant, right? Yeah. So you'll see the patient number, the height, the weight, but now the BMIs are changing, which is good. Because we do want different BMI values for each of the patients. So the issue though that we now have is that BMI is supposed to be greater than 1. The range of BMI values is never going to be less than or like in the decimals, right? So now we run into another issue that we can work through, but then we have to kind of, you know, fall in and look at the oracle or like what the original formula is, right? Okay, so there's a couple different things that are wrong with the BMI calculation. But what we'll go through first is when we look at patient height and patient weight. These numbers they don't make sense to me in terms of like the normal scale of like inches or pounds, right? So first we have to figure out what these units are and what units do they typically use for calculating BMI. So we're manually calculating BMI. So BMI is weight in kilograms divided by height in meters, right? So, so when we're looking at that, that's the equation that we're going to do. Let's see. If I'm thinking about it in like terms of like numbers that would make sense in what I'm thinking of, like in terms of like in pounds and in inches, I have to see what that looks like if I don't know what that that immediate conversion looks like. So So pounds to kilograms. Right, so if I have, let's see, like 150, that's 68 kilograms. And that's like, that makes more sense in terms of the numbers that we were seeing, right? So we were seeing like larger numbers, like 70 or 80, 150. But we're not seeing like 1.8, 1.9, 1.7. For this though, it's saying that like 70, 80, and 150 is for height. And weight is like 1.8, 1.9, 1.7. So it's possible that our previous programmer gave us the wrong data or mixed up the list naming. So when we switch these, we can double check too to make sure that our height is, so they wanted it in meters, right? So what is it from feet to meters? So if I put like 6 foot, then I'm getting 1.8 meters, right? Which makes more sense for what we're looking at on this side. So 1.8 meters is 6 foot, and then 150 pounds is close to 70 kilograms. So if we switch these and we do the calculation that we had changed, where we're setting patient number equal to I, we should get numbers that are closer to the BMI that we're looking at. So we're no longer getting those that are less than 1. So I'm just doing like a rough and dirty version of the debugging process because I know what I'm looking for. But sometimes it takes like looking at the values, or like sometimes it takes checking it in the function, or trying different things in the for loop to get to the point where you're getting good data. So, yeah, okay. So for debugging, and I know that I've talked about it in very like abstract terms in terms of like testing things. So we do use print statements to kind of start off. But as we get more advanced, we can look at adding in assertions to our code. And these are kind of like building in error checking. So this is not necessarily something that the errors can check themselves because they don't know that they're looking for it. But assertions are an easy way to make sure that we're that you can kind of provide your own error message for as you're going through. So an assertion is like, it's going to look something like this. And this is something that checks to make sure that the number is greater than 0. If it's true, it'll keep going. It won't actually print anything. But if it's false, it'll print this and it'll stop the program altogether. So it'll print data should only contain positive values. So in the code that we have, is there any space where we would theoretically check for negative values? Did we check it while it's in the function? Yes, we can check it in the function. We can also check it in the for loop. But since these patient data and lists, since they're already kind of established, we wouldn't check it necessarily in there unless the code will change so that someone's manually entering in height and weight. So what does that look like though? Let's put assert. So the assertion command is assert condition. And then this is the error message. So the condition that I want to check is to make sure that either height or weight is a positive number. So we'll just go for weight is greater than 0.0. So then we'll say weight is less than 0. So,
Smaller
hmm?
than. Smaller than 0.
Mhm. Yeah, so basically, if this is true, then it'll continue. If it's false, then it'll give this output. So for example, let's see, so if we make this a negative 85 instead of a positive 85, we can run this section. Oh, wait. All right, so we get this error. Weight is not defined. So what should this be instead? Patient weight. Patient weight. Patient weight. All right. So, what we expect to happen is that it'll be fine for patient 1, or fine for patient 0, fine for patient 1, and then it'll have an error for patient 2, right? Because that's the only one that's a less than 0. So when we run it, we get a value for patient 0, a value for patient 1, and then we get an assertion error. And then here we have the exact error message that we set. So this is something that can be checked by Python itself, the like less than 0, but if you're looking for example, like an age range where it has to be like greater than 18 or less than 36, these are conditions that you can put in your code that won't be like a generic error that you already have. And so that's why these exist. And there's 3 different types. Oh yeah, question.
Yeah.
Yeah.
I'm just making sure I'm understanding. So if there are assertion errors and you're doing this in a for loop, let's say we had like a much bigger data set than these 3 patients. Would it run the entire loop and give you an error at each point, or would it stop at the first one?
It would stop at the first one the same way that it's like an error will stop for any of the things.
Okay.
I'm not sure if we talk about it in the intermediate Python, but there are ways of kind of catching it, giving the error messages and continuing. And those are like try catch exceptions. But so yeah. So that's what that kind of looks like for assertion, and that's why we do assertions, so that we can generate our own error messages and stop it before it starts calculating things that don't make any sense. Does that make sense? Okay.
So that's same as the function for if else.
Right, but it will stop the program as opposed to just continuing. Yeah. Okay, so there's 3 different versions of assertions. There's the precondition. So for example, the precondition for calculate BMI, we want to make sure that the weight and height are the correct values or within the range that we're expecting them to be. The post condition will guarantee that can guarantee that like the BMI is greater than 1 or within that like appropriate range for like more like 22 or 50, wherever it lies. And then for the invariant, it's for this one is rough because it's always true at a particular point inside a piece of code. It's just like a generic, it's not at the start and it's not at the end, it's just like in the middle. So in some cases, if you're trying to like make sure that you are checking a value, but it's in the middle of your code writing, then that's where it would be of like, oh, it needs to meet a threshold and then we can continue going on. Yeah, so that's debugging and assertion. And I know that that's a little bit more complicated than what we've been previously talking about and as we've been going through it. But these are kind of best practices if you don't want to just rely on like the error messages or the, yeah, or getting error messages as well as like the help text of like, this is something that I'm checking, but I need to make sure that it stops the program if it runs into this error. Yeah. Okay. So, so another kind of stopping point, just before we get into the more features of Jupyter and what to do moving forward. Are there any lingering questions on like the last couple sessions that we've done or debugging and assertion in general? Any online? Okay. Cool. So, as you've been using Jupyter Notebooks for today, there are some features of it that are really helpful. So like combining text and code, being able to see the code output in real time. Later on, we'll get to see, like, you can see the visualizations or images in the code blocks or in the markdown, which is really neat for presenting your research. You get a live interaction with code, and then you can document code samples. So for example, all the different types of things that we were doing with this code, we can have different documentations for like, oh, this code block is where I'm specifically like testing out assertions, or this code block is where I'm checking to make sure why it's showing up as 0.0003 for a BMI. So, so in terms of visualization, in terms of visualization, that requires you to import some packages, and we'll talk about that a little bit now. When you're importing packages, that's what the statements will look like. NumPy is like a numerical Python package. Pandas is for data visualization and manipulating your CSV files. And Matplotlib is this specific like subspace of Matplotlib is for plotting. So when we run this, we'll get an error here that says no module named NumPy, which means that it hasn't been installed in our system. And sometimes that'll happen. Sometimes you'll have to import and install the packages before you want to run your code. Oftentimes it'll either be a standard Python package that you can just install using pip, but other times if there's code on GitHub or like a software that you want to use that's on GitHub that works well with Python, you would have a different way of installing that, but you can still work with it with your Python code. So, so how we want to do this, or how we want to incorporate these is we'll do, pip3 NumPy is how we install NumPy. Pip3 install NumPy is how we install it through pip. For those that are like following along, I would not run it just because it will take a long time to finish. It may take a long time to finish, and that is when we use this square button here, which will stop whatever we're running. Many a time use that one. So you'll basically see as you run it, which I'll do right now. Oh, just kidding. Where's that?
Exclamation point.
Oh, that's right. Okay, so we'll put an exclamation point in front of it because this is a command that would normally go on the terminal. And so the Python interpreter has no idea what that is, which is why it's giving me a syntax error. Oh, another thing that I wanted to mention. So as Jose was going through it, he specifically mentioned that like the tracebacks will tell you where the error is happening. Sometimes Python will be wrong and it's like around that error as opposed to specifically on that. line. So that's something to keep in mind as you're either going through and debugging or you're checking for errors, that like it may be below or above where it says the error is. If you're like, that line is perfectly fine, I don't know what he's talking about. So we'll run this. It'll have the star if it's running and if it's processing. So if we click stop, it'll give a number and then it'll tell you like error, like it's been stopped. But this will basically will allow you to download any packages that you want to use moving forward. Okay, so last bit, the Jupyter Notebook limitations is that the notebooks are not self-contained. So for example, if you want to take this Jupyter Notebook from the environment that you have it in now and put it on your local computer, it's not gonna save, it may save the code that you've written, but it won't save all of the outputs that's been printed to the screen. You'll have to run them again. Because Jupyter Notebooks has a separate file that saves all those checkpoints. So like you'll see here, last checkpoint is 4 days ago. And then sometimes you'll have to click the save button for it to save. So those don't transfer when you just transfer the file itself. To run Jupyter Notebooks, you need to have Jupyter Runtime and the libraries already installed in whatever environment that you're working in. So Jupyter Notebooks isn't in charge of managing that. That's on like either your virtual environment or your Conda environment. As you saw from like the beginning half of session 4, the interactive debugging is very like hit or miss of like, okay, like where am I putting in print statements to fix things, or where am I putting in assert statements? There are other development environments that will already have that as like, oh, okay, like you want to stop your code here and see what your variables are at this point, like we can do that. Jupyter Notebook does not do that. So after we finish up the this space, I'll just go through and show you a couple different programming environments where you can do Python. Some of them are Python specific and other ones are just like language agnostic, but will have Python like capabilities within it. And yeah, I think that's it. Are there any questions on things before I move into the slides? Okay. I might have lied to you because I told you that mine was going to be very complicated coding and I've just been talking this entire time. So it's a wind down. It's a hangout. Okay. So any questions online also? No? So say you want to program something, you like the Jupyter Notebook feature, you don't want to install it on your computer. There is a Collaboratory, which is a Jupyter Notebook alternative. It's in Google Drive, which means it's shareable. But unfortunately, it's very hard to synchronously edit. And if you're used to Google products, you're used to like, oh, everyone can just edit the same file. So this is more for sharing. And then that same issue of like building your environment with the packages that you want, that doesn't necessarily transfer over if you're sharing it with a collaborator. Okay, so how can you code in Python if you just want to just straight code and you just want to do it all sequentially and you don't have to worry about the code cells, and you don't really want to, you only want to make comments with the hashtag or the pound sign in front of it? You can do that in Notepad. You can do it in Python idle. And that's like, this here is Python idle. So basically it's kind of like when you're putting in like equations and calculations in your calculator, you do it one line at a time, and then it kind of just saves what you have previously. This is really handy for when you're establishing variables, like it'll save those and then you can reference them later, but it is really hard to keep track of. So there's just kind of like pros and cons to every single place of coding in Python. Jupyter Notebook is under the umbrella of Anaconda, and Anaconda comes with a bunch of different tools that you can use, so you can pick and choose which one like works best for your workflow. And we'll jump into that, I think, as we go forward. Yeah. So I've been talking about like environments and development environments kind of interchangeably, but so there's between the IDEs, integrated development environments, and code editors are really focused on just the syntax highlighting. So when we were looking at Jupyter Notebook, we saw that like some text was highlighted in green, in blue, in red. That's like all you're really gonna get from code editors. And then of course, having that ability to like run it, see what fails, and then run it again. Integrated development environment has more features on debugging where you can stop the code wherever while you're running it. It allows you to auto-complete code so you can tab over when you're like, I know the start of this variable and I'd like to continue on. And then of course, a like more functioning version control that's like, this is what's happening in this particular area. Versus just like, I've saved it and this is my new save state. So the different code editors with Python support are Sublime Text, which is here, displayed here. And you can see that like the comments are in green, the import statements are in purple. It's also very tiny, so I apologize for that. There are code editors with Python support in the terminal, like Emacs, VI or Vim, and Nano. And then Visual Studio Code kind of combines everything in a space, so you can see the visualizations as well as the code. And you have version control, where when you're saving it, you have a commit message that says like, this was the fix for this error that I was experiencing. There are general IDEs with Python support, which means that this is not particular to Python. You can use it for R, for MATLAB, for C++, but it will support Python programs if you're running it from there. And there's specific add-ons. So I mentioned Visual Studio before, but Python tools will like enhance the process of like debugging. So here, the console will say like, okay, this is what's happening in your code and this is where you're going. So there are Python specific editors so that you can't really program it in any other language. I'm a particular fan of Spider, which is also under that same Anaconda umbrella as Jupyter Notebook. So it allows you to look at both your file explorer, the different Python files that you have that might be working in the same project. And then you kind of get a full variable explorer display of like, these are all the variables you've created and this is the current value of them, which is something that Jupyter Notebooks doesn't have. You have to kind of keep track of that on your own and you hope that you don't overwrite something that you've created. And then here, you're also able to see any plots that you've made in a window. They can also come out as separate windows, but I like having everything all in one space. And we have previously used Spider for our intermediate Python workshops to get just kind of another step up in terms of like Python IDEs. So I mentioned Anaconda Navigator and I mentioned that Jupyter Notebook and Spider are under this umbrella. So they have a bunch of different tools. We're most familiar with IPython, which allows you to like kind of have a terminal command line version of Python. That's same where you're interacting with it like on a like line by line basis. And then a Jupyter Lab, which is somewhere in between Spider and Jupyter Notebook, where you're able to have those different cells where you're testing the code and the markdown, where you don't have that in Spider. In Spider, you only have the Python files that are sequential. So that is a lot. A lot of those are free. When you're running code on your personal computer, depending on the data that you're using, and the capacity that you need, it might be a lot. So moving forward is kind of the space where I tell you like, this is what's recommended. If you think that like doing some testing on your computer is totally viable, but maybe for like longer research, like if there's a program that's gonna run on your computer for 14 days, maybe don't like destroy your computer that way and offload it onto something that's that FSU can provide as a resource. So, any questions on IDEs or Jupyter features? Okay, any from online? No. Okay. All right, so, FSU resources, my FSU V Lab, I, understand that a lot of our live stream viewers are using my FSU V Lab to follow along with our exercises. And so they're essentially doing the same things that you guys are doing in person with the Jupyter notebooks, but it's just hosted by, a different, section of IPS. But you can also do the Research Computing Center, which is what the in-person people are doing, with their workshop accounts. And if you want a more permanent account than the workshop account, if you are a undergrad student or a graduate student, you'll need a faculty advisor that'll just sponsor you. If you're already doing research, that's something that they can just to kind of make sure that like, oh, if like you either leave the university or you graduate, that your account just doesn't lie dormant for a very long time. But we have Jupyter Notebook and Spider, and you're able to install the Anaconda Navigator on our systems to keep doing more Python. I would say the other thing that's important, if you do want to retain the copies of the files that you've worked on throughout today, and retain all of your hard work, we can walk you through like downloading all of your files to your computer, because we will refresh all of the workshop accounts before the next workshop, so you won't have access to those files anymore. So we can help you with downloading them to yours, and then we'll also send out the solution manual if you'd rather have those along with that video recording. Okay, so the learning doesn't stop here. This was just one day, and obviously you can continue and like review the stuff that we worked on for today with the recordings. But if you're looking for more than that, there's a bunch of resources online. Python, like .org has a whole recommendation for beginner Python resources. GitHub has a bunch of Python resources that are even textbooks, just like a digital textbook. From, I think O'Reilly has a bunch of digital textbooks regarding Python that we use often enough in our teaching materials. A lot of the materials that we have created today that you have looked at are modified and adapted from the software carpentries. And they have a lot of different lessons outside of Python, but they do go through step by step, and they have those longer explanations of like, this is why things are happening, and this is what you should be expecting. Programming Historian is not necessarily, so it is a Python resource. It's not only a Python resource, but it focuses on examples that are not just like mathematical ones, or like for the most part, the ones that I am most familiar with and that I've used personally on Programming Historian are like the text analysis ones, or the programs that we're doing like sentiment analysis. So things that are not necessarily like numbers based. And the last resource that I have is particular to the Research Computing Center. We have an HPC driver's ed that focuses on how to use Python. Like there's a specific module that focuses on how to use Python on our systems with regards to Python virtual environments, Conda environments, installing packages, which might be helpful for you as well. And the media on our HPC driver's ed is a mix of linking out to documentation, more of Jose's beautiful voice telling you exactly what you need to do. And yeah, I think, and we're kind of working and building it up so that it can become a resource for people that are interested in HPC, that might have a particular programming language that they're interested in. And there's a lot of different, like, I guess, to extend past just Python, there's resources on there. Lastly, we have the Intermediate Python workshop on March 25th. and that'll be in the Direct Science Library. And that will focus on creating plots, working with multiple Python files, working with some data visualization. So if that's of interest to you and you really enjoyed how today went, feel free to sign up. It's gonna be it should already be on the FSU calendar. So just click I'm interested, but that'll be, I believe, after spring break, a couple weeks after spring break. So I've gotten a couple of bits of feedback from some people, but we would love if you could fill out a survey to just kind of let us know how today went. We're always trying to iterate over like how we've done it. This is our 3rd year doing the Python Bootcamp. And every year I think we've had to have more prep to go through that process. The other thing that's included in the survey is what topics would you like to cover in intermediate Python? So if you heard me talking about like all of the different things that we plan to cover in intermediate Python, you're like, oh no, I don't want to do that. Feel free to make suggestions because we have not finalized what we're teaching for that. And so if there's a bigger interest in text analysis or sentiment analysis, then we can pivot what we're teaching for that. And I think that's really it for all we have. Does anyone have any questions? I know this was also like, it's been like not down, but the energy has kind of waned and waxed as we've gone. Post lunch is always rough. Also 3 p.m. slump. We're working against a lot of different things, and I talked the entire time. So if there are any questions or things that you guys come up with that you want to know more about after the workshop, let us know again at support@rcc.fsu.edu. But we'll be sending out those recordings and the solutions as well as this presentation so that you can directly click the links for learning resources in Python as opposed to just trying to like find them based on me chatting about it. Yeah.
I cannot register for the intermediate Python. Is that open?
It's not open yet?
It is. I was able to.
Okay. Yeah, so see me after or see one of the moderators and we can help you out with that. But yeah. But if you have questions, you can come up. If not, then that's really it. Thank you guys for making it the whole day. We appreciate like being able to help you learn Python and being part of your learning journey. And we'll catch you at the next workshop.
Thank you.
Thank you.